Welcome back to the Software Development Week by Simplilearn. So far, we have discussed the fundamental building blocks of software development, the data structures and algorithms. Worried that you missed out on those? No problem. We'll have them linked in the cards and description box below. As announced, we will be getting started with the whole programming language today. And also, we will dive deep into object-oriented programming concepts in detail. So far, we have learned the fundamentals using both structured programming language and object-oriented programming language. And clearly you must have understood the advantages of programming using class and object-based approaches. Object-oriented programming makes the software development process more streamlined and secure. Well, how exactly is that? Don't you worry, our experts will now take over and explain them to you in a more detailed way along with practical implementation for a better learning experience. Now, over to our experts.
We will start by understanding the introduction to C++ programming. Then we will learn how to download and install C++ in Windows. After that, we will learn how to write the first program in C++, then types and variables and if-else statements. We'll also look at the loops in C++ and functions in C++ along with call by value and call by reference. After that, we will explore topics like arrays, strings, pointers, memory management, along with hands-on examples. Then we will cover object-oriented programming topics like classes in C++, OOPS concepts, and operator overloading. And at last, we will cover some topics like vectors in C++, STL, and C++ enumerations. We'll also cover all these topics with hands-on examples so that it will be easy for you to understand. So without further ado, let's get started. So let's start with the introduction to C++ programming. C++ is a popular programming language introduced by Bjarne Stroustrup in the year 1979. The aim was to make a dynamic language that is efficient and has some additional features to C. Initially, it was called C with classes as it was an extension to C language, but later renamed as C++. It is general-purpose case-sensitive language and it is called pre-compiled language because it converts the source code directly to the machine-understandable code. It is an intermediate level language because it contains both features of high-level and low-level language. C++ supports the features of object-oriented language like encapsulation, inheritance, polymorphism, etc. It also supports procedural programming and functional programming as well. Welcome to this video where we'll be telling you how you can install C++ on VS Code and Dev C++. To download VS Code, let's go to Google and search for Visual Studio Code or VS Code. We'll click on this first link. This is the official web page for downloading the Visual Studio Code. And we'll now click on this Download for Windows blue button. And now we'll click on Download Now. Here it is getting download, and as you can see, thanks for downloading Visual Studio Code for Windows. Once we are done with the download, we can click on this Open folder. Here it is. Now we need to install this file, so we'll double click on this file. And this is the setup wizard. We'll click on this I accept the agreement. And we'll click on next. As we have accepted the license agreement, now we can select our destination folder or we can leave it as it is. But make sure there must be 293.2 MB of free space on that particular disk space. Now we'll click on next. Here we can again click on next. There is no need to change over here. And now you can click on this create a desktop icon button or anyone else as per your choice. Now we'll click on next. And now we'll click finally on install. It is getting installed. It will take some time. Now we can click on this finish button. Launch Visual Studio, we have marked it. It is already marked. So when we click on this finish button, it will launch the Visual Studio code. So as we can see, this is the Visual Studio code. So as we have installed VS Code, now we have to configure it so that the C++ programs can run in this code editor. So in order to do that, we need to add some extensions. So we'll click on this extensions button. Now here we will write code runner extension. We'll write code runner, and this is the extension. We'll click on this install, and it is getting installed. Here are some instructions. We can click on Ctrl plus Alt plus N, or press F1 and then select type run code, but we'll deal with that later. Now we'll add another extension, that is C/C++. Here it is. We'll click on this install. Here we can see downloading Visual Studio Windows Debugger. It is getting installed, and I think it is installed now. So as we have added both the extensions, so let's move on and do a program of C++ in this code editor. So the first program for beginners is Hello World program. In this program, Hello World is printed. It is very basic program, and in the first part of the program we are including a header file #include iostream. Header files are generally used to import features into the program. Functions like cin, which is used to take the input from the user, and cout, which is used to display the output, are defined in this iostream header file. Here using namespace standard means we are using all the things which are within the standard library. The second part of the program is main function. This is a special function from where the execution of program starts. Inside the main function, we are printing Hello World using the cout, which is used to print the output. Return 0 on the next line will indicate the program that nothing will return and program executed successfully. So let's try this Hello World program on our code editor, that is VS Code. So let's first of all name the file hello.cpp. So first of all we'll include the header files #include iostream, and then namespace standard we'll write using namespace std. Now we'll write the main function, that is int main. Now inside this function we'll print using cout, and we'll write hello world. After that we'll write return 0. Alright, now let's try to run this. As we can see, Hello World is getting printed over here. So this is how it's done. So now let's move to our next topic, that is types and variables. Coming to types and variables. In C++, there are different types of data type that acts as a keyword, which is responsible to define a variable. First is Boolean data type. This keyword is used when we have two values, either true or false, and these values are used when there are conditions. For example, if the condition is satisfied, then it's true, otherwise it will return false. Next is character data type. This character data type is used when we are dealing with alphabets and symbols, and it is used to hold a single character within the variable. Integer data type. This data type is used for integer values. They can be both positive and negative. Next is float data type. Float is used when we want to store values that are in decimal form. Now, variables. Variables are used with these data types. It is generally used to store values. And this is the syntax to define a variable. First, we will mention the data type and then the variable name of our choice. For example, int is the data type and data is the variable name. Our next topic is strings. We can define strings as a collection or group of characters. It is basically used to represent text in the program, and we can perform many operations on strings in order to manipulate it. The syntax of string contains a collection of characters surrounded by double quotes. For example, here string is the type, str is the name of the string, and coffee is the value that is assigned to the string. In C++, there are two ways to create a string. First is C-style strings. In C-style strings, collection of characters are stored in the form of arrays. They are basically arrays of type character. The second way is using string objects. We can create string object to hold a string. They are implemented in the standard library, which we must include in the program using #include. Now let's move on to the next example. So let's make a new file and name it as basic3.cpp. So here we will do an example of string and we'll do some push back and pop back operation on it. So first of all, we'll include the header file #include iostream. Then using namespace standard, Okay, now we'll start with int main. Alright, first of all we'll write string data type, then the name of the string s. Here s is the name of the string. Alright, now first of all we'll display a message to enter a string. So okay, enter a string. Now get line. This is the syntax when you want to take the input of a string. So get line cin is used to take the input and s is the name of the string. So this is how we take the input, and now we will print another message saying that you have entered Now here we will print the string s. Next line and l. Okay, now we'll do some operations like s dot pushback. This will add an element at the end of the string. So let's say we want to add y. So we'll write y inside the bracket, s dot pushback, and inside the bracket with single quotes we'll write y. Now we'll display a message saying after using pushback function, we'll print the string. That is, after using the function pushback, the string would look like this. And now we'll use another function s dot popback. It will delete the element from the end. So we'll write cout and we'll display the message after using popback function. Let's write popback only and we'll print the string. Okay, now after that we'll write return 0, and I think it's done, only the spelling is wrong over here. Okay, yeah, now let's try to run this. As you can see the message, enter a string. So let's say I have entered Barcelona. So you have entered Barcelona after using pushback Barcelona y, because we have used y over here. We want to add y at the end of the string. So after using pushback Barcelona y and popback function after that we have used, and we know that it will delete the element from the end. So here we can see there is no y. Popback function have deleted the element. So this is our output. Next is if-else statements. If-else are two conditional statements that are generally used when we want to run the code based on some conditions. We run a block of code which is inside if statement only if the condition is true. For example, if the number variable here is equal to 10, then only the block of code will execute and will print the message you got it. Otherwise, it will run the else block and display the message written inside that block, which is not this one. So first of all, we'll create a new file. We'll go to file and click on this new file. Now, in order to save this one, we can click on Ctrl S, or we can go over here and click on this save as. Now we can select the location, like let's keep it over here only. Let's name it as visual.cpp. .cpp is the extension which is used when we want to do a program in C++. Now we'll click on this save button. Now let's do a simple program to check whether the program is running on this code editor or not. So we'll include the header files, #include iostream. Now we'll write namespace standard. Now we'll write int main. Now inside int main we'll display a message, welcome to this video. Okay, now return 0. Make sure to save this after making changes, or you can click on Ctrl S, or you can go to file and click on this save. So once you have saved the program, now you can run it. We can click on this play button. It will run the code. As we can see in the output, welcome to this video, we can see here it is. So it means our program is working, it is running fine. Now let's do another example in which we will take the inputs from the user. So let's make a new file. We'll go to file and click on this new file. Now we'll save as and we'll write visual2.cpp. Alright, in this program we'll take the input from the user. So start with header files, #include iostream. Our spelling is wrong. #include iostream, after that using namespace standard. Now inside int main we'll take the inputs from the user. We'll display the message, enter the first number. Now using cin, we'll take the input. We forgot to mention this, declare this n1 variable. So we'll write int n1, int n2, and int sum equals 0. Alright, here we have taken the input of n1, the first number. Now we'll take the input of another number by displaying the message. Enter the second number. We'll write n2. Now we'll add both of these, n1 plus n2, and we'll display the result. We'll write end line so that it looks good. Alright, now we need to save it. We'll go to file. I'll click on this save. Now it is saved. Now we can run this program. We'll click on this run code. Now in order to write the first number over here, that is, in order to write in the terminal, we have to configure the Visual Studio Code. And to do that, we'll go to file and we'll now go to preference, and in the settings we'll click on the settings, and here we will type run in terminal. Alright, now we can scroll down and here we can see code runner run in terminal. In my VS Studio it is already marked, but you have to mark this if you want to write in terminal or enter the inputs in the terminal. Alright, once you have marked this, you can close it and then you can Control S, that is save, and then you can close the VS Studio and then open it again. Once you are done, now let's try to run this. So now you will be able to write the inputs, like let's say 4. The first number is 4. Now the second number, let's say 9. On addition it becomes 13, which is the right answer. So these were some configurations that you need to do if you want to run a program of C++ in Visual Studio Code. So as we have understood how to download and configure Visual Studio Code for C++ programs, so let's move on to learn how we can download dev C++ and run C++ programs in that. So let's go to Google and type dev C++. This is the first link. We'll click on that. Now this is the green button saying download. We'll click on that to download dev C++. As you can see, it is getting downloaded. Your download will start shortly. So now we'll click on download now. Now it is getting downloaded. It will take a while. The size of this file is 48.1 MB. So as you can see, the downloading is almost done. So the downloading is complete. Now we'll click on open folder. Here it is, dev C++ setup. Now we'll click on this setup. We'll click on yes. the setup is loading. So now here we will select the preferred language. It is English. We'll click on OK. Now we'll click on, this is the license agreement. We'll click on I agree. Now we'll click on next. We don't need to change this. I think the space required is 346.8 MB, and we'll click on next. Now if you want to change the destination folder, you can, but I don't want to change it, so I'll click on install. Now it is getting installed. It will take a while. It's done, and now we'll click on finish, and it is marked. So when we click on finish, it will launch the dev C++. So here we have to select the language. It is English, so we'll click on next. Here again we'll click on next, and now we'll click on OK. So this is our code editor, that is dev C++. So let's write a code. First of all, let's create a file. We'll go to file and go to new, and we'll click on source file. Alright, now we need to save this one, and in order to save this, we'll click on file, then we'll go to save as, and now we'll select the destination and name it as dev.cpp. Alright, now let's start with the header file, hash include iostream. We'll do a simple program over here using namespace std, because we want to check that whether the program is running in this editor or not. Namespace std. Now we'll write int main. Inside int main we'll display a message, welcome to dev C++. Alright, after that we'll write return 0. Now let's try to run this, and in order to run this program, we'll go to execute, and now we'll click on compile and run. Here this is the pop-up, welcome to dev C++. As we can see, this is the output. Now press any key to continue, it will close this window. So our output is correct, welcome to dev C++. So this is how you can run a program in dev C++, and our program was also working fine in the Visual Studio Code.
Moving on to while loops. In order to perform a particular task or operation many number of times, we need loops. These are used when we want to execute a block of statement repeatedly rather than just writing those statements again and again. For example, imagine you want to display your name on the screen 50 times. Now to do that, there are two methods. Method 1 is writing your name 50 times by doing the hard code. And method 2 is writing your name once with the loop condition, and your name will be automatically displayed 50 times. Now it is pretty obvious that you would prefer the second approach because you don't have to put effort in writing your name 50 times. Plus, it is easy to write code in few lines. So method 2 is the functionality of loop. It reduces time in writing the code, plus it increases the simplicity. Now let's understand what is a loop. Loops in computer programming is a series of tasks that are used to run some particular code repeatedly until a specific condition is met. Loops tells the computer when to start the condition and when to stop it. Now this is a basic flow of a loop. After the initialization, the condition is checked. If it's true, then the block of statement will get executed as long as the condition is true, and if the condition is false, the loop will terminate. Depending on the program, different types of loops are used in different times. So let's first see different types of loops. First is for loop, then while loop, then there is do while loop. After that there is nested loop. These are four types of loops in C++. So let's discuss these loops. First is for loop. It is a repetition control structure that is used to iterate a piece of code based on the condition is true or false. If the condition is true, the statement inside the loop body is executed, and once if it returns false, the execution of statement will get terminated. And after every execution of for loop, the increment or decrement parts will update the loop counter. Now let's move on to the while loop. In this loop, the condition is evaluated first. If it's true, then the set of instructions inside the loop body will execute, and this will happen repeatedly until the condition becomes false. And when it becomes false, the loop will end. Now, the main difference is we use for loops when we know the number of times the body of the loop needs to run, whereas we use while loops when we don't know the accurate number of times the body of loop needs to run. Now, moving to the next loop, that is do while loop. This loop is quite similar to the while loop. In this, the loop will execute the set of instructions once before checking if the condition is true. After that, it will repeat the loop as long as the condition is true. That means, in do while, loop body will execute at least once irrespective of the test condition. Now, coming to the nested loop. When one loop is defined inside the body of another loop, then it is known as nested loop. In C++, there are at least 256 levels of nesting. And the flow of execution for nested loop is, first it includes initialization of variable, followed by condition 1. If it gets satisfied, then it will search for the second condition. If that also gets satisfied, then it will get increment, and when the condition gets satisfied, it will search for the new set of statements, and follows the same flow of execution. Now coming to the control flow statements. First is break statement. It is basically used to come out of the loop instantly whenever a break statement is encountered inside the loop. The control directly comes out from the loop by terminating it. Basically, break statements are used when we are not sure about the number of iterations or we want the loop to end on some condition. Now we will discuss about continue statement. Continue is also a loop control statement. It is used to skip the current iteration of the loop and control of program goes to the next iteration. In other words, if continue is mentioned inside the loop, it skips the current statement and transfers the control to execute the next iteration of the loop. Now, as we have discussed these topics, let's do some examples to understand them better in our code editor, that is VS Code. Now, we'll make a new file and we'll name that file as loops.cpp. Okay, loops1.cpp. Now here we will do a program in which we have to print the digits from 0 to 10 using for loops. It will be a basic program just to understand it. We'll write the header file #include iostream. Now we'll write using namespace standard. Now here is the int main. Now we'll write the for loop with a for keyword. Inside the for loop, we'll initialize I with 0. Now we'll put a condition I less than equal to 10, which means the loop will keep on executing until I is less than 10. Now we'll put increment I++. Now inside the loop brackets, all we have to do is to print I, so that all the digits get printed. So now let me tell you, here what we are doing is, we are just making the loop to run from 0 to 10. As we can see that I have made I 0 to I less than equal to 10. That means loop will move from I 0 to 10. Now let's try to run it. Here we can see all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is our answer, and let me tell you one thing more. To put return 0 after the loop, it's a good practice. Now I'll again run it. The output will be the same, but it's a good practice to write return 0 in the end. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of writing the hard code, we can just use the for loop in this case. It's a basic example of for loop, but you can try some more examples in order to understand it better. Now let's do one example of while loop to understand it better. We'll be doing a basic example of while loop in which all we have to do is to print Happy New Year 11 times. Let's start. First of all, let's name this file loops2.cpp. Now let's start with the header file, that is hash include iostream. Now we'll write using namespace standard. Now here's the int main. Now first of all, we'll declare n equals 0. We'll take a variable n and initialize it with 0. Now we'll put the while condition with the while keyword, writing while n not equal to 11. Here what it means is the loop will keep on executing until n becomes equal to 11. Now here all we have to do is to print Happy New Year so that it will get printed along with the loop 11 times. And now we'll write n plus plus. We have written n plus plus so that the loop will keep on incrementing every single time. After that, now we'll write return 0 outside the loop. Now we'll try to run this. So here's our output, Happy New Year 11 times. So this is how it's done. This is again a basic example of while loop, but to understand it better, one must practice some more examples on it. Now let's do one example of do while loop also. Let's make a new file. First of all, let's name that file loops3.cpp. I think the name is already taken. Then we'll write loops4.cpp. Okay, now so we'll write the header file. First of all, we'll write hash include iostream. After that, using namespace standard, now in this program, all we have to do is we have to print the sum of all the digits from 0 to 9. So let's start. We'll write int main. So now let's first of all declare a counting variable sum and initialize it with 0. Now we will initialize another variable I with 0. Now the syntax of do while loop is do keyword, and now we will add some code inside the body. We'll write sum equals sum plus I. Here what we are doing is we are simply adding sum variable and I variable and storing it to sum variable itself. We are doing this because we want to find the sum. That is why we have to store it in a single variable. Now we will need to increment I, or else loop is going to run forever. Now we will write while I less than 10. We have written I less than 10 because we want to find the sum from 0 to 9. And make sure to put a semicolon in the end in case of do while loop. Now we will print sum in this while loop. We'll write sum is sum variable. Now this loop will keep on executing till I is less than 10. Now in the do while loop, sum is calculated by repeated addition and increment. In each repetition, it is checked whether the number I is smaller or equal to the inputted number. If it is smaller, then the loop continues, but exits the loop if it isn't. After the control exits from the loop, sum is printed. Now let's try to run this code. Here it is. Sum is 45, which is the right answer. This is our output. So this is how it is done in do while loop. So now let's do one example of our last loop, that is nested loop. First of all, we'll name the file loops5.cpp. Now we'll start with the header files. Now using namespace standard, now in this program all we have to do is to print a star pattern of half pyramid form using nested loop. So let's try. We'll write int main. Now let's initialize two variables, that is I and j. Now let's say we want to make a half pyramid of 10 rows. Then it means we need to run a loop which runs for 10 times. So let's write for initialize it with 0, I less than 10, I plus plus. Now here we have written I less than 10. Instead of this, we'll write I less than equal to 10 because we want the 10th row to be printed also. Now we will print /n in order to insert a new line. Now we'll write another for loop which will decide number of stars in a particular row. So we'll write j equal to 1 because this for loop is for the column section. Then j less than equal to I, which is a row, then j plus plus. Now we'll print star. Now one more thing, instead of 0 we'll write I equals to 1 because we want to print stars from 1 to 10. So now let's discuss its working. Initially we have I equals to 1, that is the outer loop value. Now for this value a complete run of jth loop is happening, that is j equal to 1 validated by j less than equal to I. Now this condition is used because the pattern which we are gonna build is having increment of star as the number of rows increments. So for I equals to 1, j equals to 1 is executed. Then j++ is done, which increments the value of j to 2. Now j equals to 2 failed to execute as 2 is less than equal to 1 is false. Therefore, only one star is printed. Again, we go to ith loop. Now for I equal to 2, we'll check every value of j which can be executed, that is 1 and 2. Since only two values can be true, therefore 2 stars are printed. Similarly, we check for I equal to 3, 4, 5 and so on till 9, as we have the condition I is less than 10. So now we'll try to run this and check whether the pattern is printing or not. Here it is, half pyramid form using stars with the help of nested loops. So this is our star pattern. We can make some more different types of patterns using nested loops, but we have done only one example in order to understand the concept. So now let's move to our control flow statements and let's do some examples of them. Okay, now make a new file and let's name this file as control1.cpp. Now we'll write the header file and the namespace standard as we have done previously. So let's do it. #include iostream using namespace std. Now here we will write a program in which we have to print the numbers from 100 to 200, like 110, 120, 130 with a gap of 10. But after 150 we will terminate the ongoing loop. Now how can it be done? With the help of break statement. So let's start. First of all we'll write int main. Now we'll take a variable num and initialize it with 100. Now we'll write a while condition and we'll write num is less than equal to 200 because we want the loop to run from 100 to 200. Num less than equal to 200. Now we'll simply display those numbers. Now we'll write an if condition that if num equals 150, then we'll terminate the loop, and for that we have to write the break statement inside the if statement. So let's write if num equals 150, then we have to break the loop. Write the break statement. Now after that we'll increment this by 10. We're incrementing this by 10 because we want the numbers to be printed like 100, 110, 120 like this. That is why we are incrementing it with 10 and not with 1. Now we'll write out of the loop, just to be informed that we are finally out of the loop. Return 0. Now we'll try to run this. Here we can see, here we can see 100, 110, 120, up to 150. After that, we are out of the loop. This means the code works fine. So this is the example of a break statement. Now after this, we'll do another example of continue. So let's start. Let's make a new file and name it control2.cpp. Now we'll write the header files. Using namespace standard. Now in this program, all we have to do is to print the numbers from 100 to 90, only excluding 96 from them. Now how do we do it? With the help of continue statement. So let's start. First of all, we'll write int main. Now we'll declare a variable num and initialize it with 100. Now we'll write a while condition, while loop, in which we write the condition num greater than equal to 90, because we want the loop to run till it is equal to 90. That is why we have wrote greater than equal to 90. Basically, we want the loop to run from 100 till it becomes equal to 90. Now inside the loop, we'll write the if condition in order to skip 96. So we'll write if num equals 96, num equals 96. Now we'll use a decrement operator, because our starting point is 100, our ending point is 90. That is why we have to use the decrement operator. Now continue statement. After that, we'll write value is, and we'll write the variable num. Now we'll write num minus minus. Here we are writing minus minus because we want it to get decrement after printing also. That is why we have written num minus minus after printing num. Now let's try to run this also. Hope it works. Okay, I think there are some errors. So some brackets were missing. And we'll write return 0. Now we'll try to run it. Here it is. As we can see, 100, 99, 98, 97, but 96 is missing. So this is all we have to do in this program. And this is the basic example of continue statement. In order to understand these examples better, you must try more examples on each of these loops and control flow statements, so that it will be easier for you all. Moving on to what is a function. Functions are blocks of code that are designed to perform a specific task. It basically divides the complex problem into smaller portions and make the program easy to understand and reusable. And by reusable, it means we can define the code once and we can use it many times. We can also pass data into the functions in the form of parameters. And this is the syntax. First is return type of the function, then we will write function name, then inside the bracket these are the parameters. Now let's discuss why we use functions. Functions make the program less complicated because once function is defined in the program, then it can be used over and over again, which reduces the complexity of code. And it helps in avoiding the duplicity of code, and it reduces the amount of code. Due to this, we can easily debug and maintain the code. Now, coming to the types of functions. There are two types of functions in C++, that is, built-in functions and user-defined function. Now, let's discuss these functions. First is built-in function. These are also known as predefined functions or library functions. We don't need to define these functions because these are already present in C++ libraries, and the implementation of these functions are also available in library file. And to use these functions, we don't have to write them separately, we simply call them. Now coming to the user-defined functions. C++ allows us to define our own functions. These functions are created by programmers according to their requirement. This allows a way to wrap a set of statements to perform a specific task, and that group of statements is given a name so that it can be invoked later from any part of the program. Following is the example of user-defined function. Here club is a user-defined function with the return type void, and it is being called from the main function. Now let's learn about function declaration. Function declaration basically acts as an identification for the function. It informs the compiler about the existence of function's name, the number of parameters in the function, and its return type. These things acts as an identifier for a function. And this is the syntax for a function declaration. First, we will write the return type, then we will write the name of the function. After that, inside the bracket, we will write the number of parameters. For example, in this chess function, int is the return type, chess is the name of the function, and inside the brackets, these are the number of parameters. Although we can write the names of parameters, but names of parameters are not important in the function declaration, only their type is required. Now, let's learn about function calling. In order to use a function, we'll have to invoke or call a function. When a program calls a function, the control of the program is transferred to the called function, and when the called function completes its task, then the control is returned back to the main program. So the functions are called by writing the name of function, and after that writing the required parameters inside the brackets. And this is the syntax. First we will write the function name, and after that we will write the arguments which we want to pass. For example, sum is the function name and a and b are the arguments. Moving on to
another video on call by value and call by reference in C++. Call by value is a method in which copies of variables are passed to the functions, and as the copies of variables or arguments are being passed, so that is why the changes that are done inside the function does not affect the arguments. And this is the syntax. Inside int main, we can see that we are calling a function and passing the values. Here val1 and val2 are the actual parameters. These are those which are passed to the functions. And inside the brackets of called function, we can see n1 and n2. These are formal parameters. Formal parameters are those which are received by the function. So here we can say values of actual parameters, that is val1 and val2, will be copied to the formal parameters, that is n1 and n2. Now let's have a look at an example in which we are swapping two numbers. As we can see, inside int main we have assigned 120 to x and 150 to y. After that we have called a function named swapIt, and inside the brackets we are passing the values of x and y, and these values are getting received by called function, and inside that function there is a logic to swap the code with the help of temporary variable temp, and these values of x and y are then displayed inside int main. But its output is same. X is still 120 and y is still 150. there is no change after swapping it also. So this shows that actual value of the variable is not getting modified. This shows that changes done to the parameters inside the function does not affect the arguments. Now let's learn about call by reference. In this method, instead of passing the arguments, the address of the argument is passed to the formal arguments of the function, and the address is used to access the actual argument referring to the same location, so any changes that are made gets reflected to the actual parameter. This is the syntax of call by reference, in which we have assigned 200 to the variable num, and then the address of this variable is passed to the function and 20 is assigned to it. Now on displaying the output, the value would be 20 and not 200 because the value is assigned to the memory location. That is why change is getting reflected. Now let's have a look at an example of swap. This is the same example as that of the call by value, but instead of passing the copies of variable, we are passing the address of the variable, and inside the function values are getting swapped with the help of temp variable, and then it is getting displayed in the main function. In this case, we can see in the output the values of variables are actually swapped. M is now 300 and N is now 250. Now let's do some examples of call by value and call by reference in our code editor, that is VS Code. Now we will do an example of call by value in which we will try to change the salary with the help of a function. So let's start. First of all, let's make a new file and name it call1.cpp. Now we will include the header files #include iostream. Now we will add namespace standard. Now first of all we'll write int main. And we will declare a variable sal and assign a value 27,000, let's say salary, to this sal variable. Now we will call a function. Let's name that function as salary underscore change. And now inside the brackets we'll write sal, as we know that in call by value we pass the copies of the variable. So now we'll display that variable. We'll write value inside main. And now we will write the variable name sal and handle now return 0. Now let's make the function salary change. We'll write void salary underscore change. It's void. Now here we will write int, the data type, and the variable s, that is the formal parameter. Sal here is the actual parameter and s is the formal parameter. Now we will assign as a new value, let's say 30,000. Here we have assigned as 30,000. Earlier the value of sal was 27,000, and then we passed the copy of the variable sal to the function salary change, and there we assign 30,000 to it. So let's print over here value inside function. Sal and L. Here we have to write S because the variable name is S. Okay, now let's try to run this. Here we can see value inside function is 30,000 and value inside main is 27,000. Here we can see the value of the variable that is passed gets changed, but the original value inside the main function doesn't changes. So we can say changes are not reflected to the original value, which happens in call by value method. So now let's do one example of call by reference. Let's make a new file, call2.cpp. Let's include the header files, #include iostream, now we'll write using namespace standard. Now we'll start with int main. Here we will declare a variable sal and assign 27,000 to it, as we have done previously. Now we'll call a function named increment. And inside the bracket we will pass the address of sal. As we know that in case of call by reference we pass the address. So after that we'll just write the message saying salary inside main, and we'll write the variable sal, then endl. After that we'll write return 0. Now our job is to write the function. We'll write void increment and here we'll write &sign s, because here we are passing the address, not any copy of the value or the variable. Here we are passing the address of the variable, so that is why we have used &sign. Now we will simply write the logic to increment. So we'll write s equals s plus 5,000. Let's say we want the salary to increment by 5,000. Then we will display the variable s. So first of all we'll write the message salary inside function, the name of the variable, after that endl. Now let's try to run this. Here we can see that the salary inside the function is 32,000 and salary outside the function, that is inside the main function, is 32,000 as well. Here we can see that the changes are reflected to the original values as well in the main function, and we know that in case of call by reference, any change inside the function is reflected outside the function because we are passing the address of the variable. So this is our output, 32,000 and 32,000. So these were some basic examples of call by value and call by reference.
Now here we will do a program in which we have to do the sum of two integers with the help of function. So let's first of all make a new file, function.cpp. Okay, so let's start. First of all, we'll declare the header files, that is hash include iostream. Now the namespace standard. Now we'll write int main. Now inside int main, we'll declare a variable named s. Here we have declared this variable because we want to store the sum of those two integers in this variable. So we'll call the function, let's name the function as sum, and let's assume the variables to be 5 and 5. Here sum is the name of the function and 5, 5 are the arguments. Now we'll make the function sum. Here int is the return type, sum is the name, and int a, int b are the parameters. So in this function, we'll write the code to do the sum of these two integers, and for that we have to store the sum in a variable. For that, we will now declare a variable c. Now we will write c equals a plus b. Here we are storing the sum of a plus b into the variable c. Now as we know that the return type is int, so we have to return the variable instead of printing it. We'll write return c. Now in the main function, we'll print that variable. We will print the variable s because after the function completes its task of addition, the output will come back to the calling function, which is getting stored in the variable s. So we'll write the result is now we will write the variable s. Let's see. Hope it runs. The result is 10. 5 plus 5 on addition will get 10. Let's write 3 and again try to run this. The result is 8. 5 plus 3 equals to 8. So this is the right answer. Now we will do another example of C++ function in which we have to find the larger number or greater number among two elements. So let's do that. Let's create a new file. function1.cpp. Now we will include the header files, hash include iostream. Now using namespace standard, now first of all we'll write the int main. Now the variable n1. Now we will declare another variable n2. These are the two variables among which we have to find the greater number. So we'll display a message saying that enter the first number. Now we'll take the input n1. Now we'll do the same for the other one. We'll write enter the second number. We'll input the second number. Now we have to make a call to the function named, let's say, maxi, and we will pass these arguments n1, n2. Now let's make this function maxi. The return type is void. Maxi is the name. We'll write the variables n1, n2. Now we'll write the if condition because we have to find the greater number among both these elements. So we'll write the if condition. If n1 is greater than n2, then it must print the n1. So we'll also display a message saying that the larger number is n1. If n1 is greater than n2, then we'll display the n1, and if n2 is greater, then we'll display the n2. We'll write the variable n2. So let's see if that runs or not. I think we have to write the first number. Here we can see enter the first number. Enter the first number. So we'll write, let's say, 56, and the second number would be 78. The larger number is 78. So among both the numbers, as we know that 78 is greater than 56, so this is how we can show it with the help of functions. So these were some basic examples of C++ functions.
In this video, we'll be discussing what is recursion. Recursion can be defined as a process in which a function calls itself again and again until a certain condition is met. Recursion basically brings about several number of iterative calls to the same function. However, it is important to have a base case to end the recursion. For example, imagine you are calling your friend again and again for an urgent piece of work until he picks up the call. Now, here calling your friend again and again or one after the other is a recursive function, and when he picks up your call is the termination condition. And this is the basic syntax where the function name is recursion and it is being called from the main function, and inside the recursion function it is calling itself. Now let's understand its working. In a recursive function there are two parts, that is the recursive case and the base case. In the recursive case, the function is being called by itself again and again, and the base case is when the function finally stops calling itself. So when the recursive function is called from the main function, then the called function will execute and it keeps on repeating as it is being called by itself from within the function again and again until it meets the base case that will terminate its calling. For example, factorial of 5. In this problem, we can see a pattern, n into factorial of n minus 1. To be clear, n is 5. So n minus 1 is 4. And it is going on till n becomes 0. Here factorial is the recursive function and n minus 1 is the argument that is getting passed for every n into the recursive function. In this case, if n becomes 0 or 1, it is the base case and n into factorial n minus 1 is the recursive condition. Now let's understand the types of recursion. First is direct recursion. As the name suggests, in this type of recursion, function calls itself directly. For example, void recursion. Here recursion is the name of the function and is being called by itself from within the function directly. Although there is no base case in this example, but it shows the idea of direct recursion. Now, coming to indirect recursion. When a function calls itself indirectly, that is, if a function calls some other function to make a recursive call, then it is known as indirect function. For example, here recursion function is calling some other function sub, and sub function is calling the recursion function. Here both the functions are calling other functions to make a recursive call. This is called indirect recursion. Now, coming to advantages and disadvantages of recursion. The advantages are, in recursion we only need to define the base case and the recursive case. So, therefore it provides a simple and clean way to write a code. Second is, recursion is more preferred in problems like tree traversals, Tower of Hanoi, graphs, because these are inherently recursive problems. Now, disadvantages. Disadvantages are, the recursive program generally acquires more space than the iterative program. This is because after every call to the function, each function call will keep on adding to the stack until the base case is reached. Second is, it requires more amount of time because of function calls. Now, let's do some examples of recursion on our code editor, that is VS Code. Now here we will do a program in which we will find the sum of natural number up to a number which we will enter, and we will do this example using recursion. So let's start. First of all, we'll name this. Recursion.cpp. Okay, now we will start with writing header file, that is #include iostream. Now we'll add namespace standard using namespace std. Now first of all we'll write int main. Now we will declare a variable, let's say num. So basically we want to enter a number. So for that, first of all we'll display a message saying that enter a number. Now we'll take the input as num. So now here we will make a call to the function, and in that function we will pass the variable num which we have taken the input of, and we will print this with a message. So let's say we'll print it like cout, and the message would be sum is, and this is the function name sum, and this is the variable which we are passing. After that, let's write return 0. Now let's make this function sum. We'll write int, the return type, sum, the name of the function, and the variable num. Now first of all we have to make a base case. So we will write the base case as, we'll make if num is not equal to 0, then here we will write the recursive case, return num plus sum num minus 1. So here we are adding the numbers with its previous number, and because of recursive condition it will keep on calling the same function, sum function, again and again till the base case, that is num becomes equal to 0, is achieved, and once it is achieved the calling would be stopped. Num not equal to 0 here means that if num is not equal to 0, then only this statement num plus sum num minus 1 will execute. Okay, so now after this we'll try to run this. Enter the number, let's say 5. Sum is 15. Here we can see sum is 15. Okay, let's recheck. 5, 14, 14 plus 1 equals to 15, so our answer is correct. So this is how we can find the sum up to any numbers which we want to find the sum of. And now let's do another example. So let's name this as recursion 2.cpp. Now here we will do a program of factorial. We will enter a number and we have to find the factorial of that number. So let's start. First of all we'll write hash include iostream, that is the header file. Now using namespace standard, now we'll write int main. Okay, now we will declare a variable number, and we want to take the input from the user, so we'll display a message saying enter the number. Now we will take the input, we'll write number. Now we will call a function and we will pass the argument number as we have done in the previous question. So let's do it. First of all we'll display that saying the factorial of the number you have entered is. Now we will make a call to the function. Let's say the name of the function is fact, and we'll pass the argument number. as we have done previously. Now we'll write return 0. Now let's make this function. We'll write the return type int. Now fact. After that, now we will write the argument int number. Now we will write if condition and we'll write number less than 1 and we will return 1. So here we have wrote this condition because as we know that the factorial of 0 is 1, and if a number is less than 1, that it means it is 0, and if it is 0, then our program should return 1. And we'll write now else condition. Else if it is not 0, that means we will write the recursive condition, that is number into fact number minus 1. Now this is the condition that is responsible for finding the factorial of a number. For example, if we input 5, then here we can see the condition would become 5 into fact 5 minus 1, that is 4. And this 4 will be passed as argument to this fact function. And then the condition would become 4 into fact 4 minus 1, that is 3. And it is also passed to the function. And similarly it will go on until it becomes less than 1. Now let's try to run this. Enter the number. Let's say 6. The factorial of number you have entered is 720, and we know that the factorial of 6 is 720. So this is the right answer. And let me tell you, this is the base case and this is the recursive case in this program. Now after that, let's do one last example of recursion. Okay, so now let's make a new file and name this file Now first of all we'll add the header files, iostream, now namespace standard, using namespace standard. So here we will do the program of Fibonacci series, and we know that Fibonacci series is basically in Fibonacci series each number is basically the sum of its two previous numbers. So let's start. So first of all we'll make int main. Now we'll declare a variable num. Now we want to take the input from the user. So first of all we'll display a message saying that enter the number. Now we'll take the input. We'll write num. Now we will make a for loop and iterate that loop from i0 to num. So we'll write for keyword int I equal to 0, I less than num, I plus plus. Now inside the loop we will write cout to display, and we will call fibo function, and we will pass I as an argument because we want to print the series. So we will write cout fibo and we'll pass I as an argument, and just for the space, now we'll write return 0. In FIBO function, we have passed I as an argument because we want to print the series. So first 0 will be passed, then 1 will be passed, after then 2 will be passed, and so on. So now we will make the function FIBO. Int is the return type, FIBO is the name. Now the argument num. Now in this FIBO function we will put if condition for checking if the num is equal to 0 or 1. If yes, we will return the value of num, else we will recursively call FIBO using n-1 and n-2 because Fibonacci series is basically the sum of previous two numbers. So first of all we'll write if num is less than equal to 1, then return num, else return FIBO num minus 1 plus FIBO brackets num minus 2, because we know Fibonacci series is basically the sum of previous two numbers. Now if the num is 0 or 1, then it will go to the if statement, and if it is greater than 0 and 1, then it will go to this recursive statement. So for example, if n equals to 2, then we will call recursively 2 minus 1 and 2 minus 2, that is 1 and 0 respectively. Since 2 minus 1 will give 1 and 2 minus 2 will give 0, these will be evaluated in if statement as they are less than equal to 1. So it will give 0 plus 1, that is equal to 1. Now let's try to run this code. Enter the number, let's say 6, 0, 1, 1, 2, 3, 5, which is the right answer. The Fibonacci sequence for 6 is 0, 1, 1, 2, 3, 5. So this is how we can do Fibonacci series or Fibonacci sequence with the help of recursion. And I suggest you to do some more examples on recursion to understand it better.
Moving on.
Why we need header files? Header files allows us to assemble all the predefined functions in one place, and it is helpful because it is easier to gather the declarations in one place and then use them whenever we need them. And as all the declarations are gathered in one place, so it automatically reduces the complexity and it also decreases the number of lines of code. There are many functionalities of header files. One of them is it helps in taking the input from the user and also helps in displaying the output in a program. Now let's learn what actually a C++ header file is. Header files are the set of libraries that contains predefined functions at a common place. So it basically stores the declarations at one common place and they are being used while writing a program. These header files usually have a .h extension, and we use #include before writing the header file to inform the preprocessor that we are including this header file. Now let's discuss types of header files. There are two types of files in C++. First is predefined header file. These files are already present in C++ compiler. We simply need to import these header files using #include, which will inform the compiler about the header file, and then we can write the name of the header file between the angle brackets. Next is user-defined header file. These header files are defined or created by users. In C++, user can create their own header file and include it in the C++ library, and it can be used whenever it is required. Now let's learn how to create this header file. In order to create your own header file, first of all we will write the C++ code. which we want to use whenever we want. After that, we will save the file with .h extension. As we can see in step 1, we have written the code of two integers that are getting multiplied. And now we will include this in the program. To include this in the program, we will use #include, and after that we will write the name of the header file inside the angle brackets with the .h extension. Here #include will inform the compiler that a header file is added. And now, as we can see in step 2, after the declaration of two integers, we are calling the function product and passing the arguments x and y. After running this program, we will get the output as 45. Because 9 into 5 equals 45, and we don't need to worry about writing the logic of it because we have already included this header file. Now let's have a look at some examples of header files. #include IOStream. IOStream is the header file that is used to read and write the standard input-output streams. Because of this header file, we can take the input and display the output. And in case of IOStream, .h is not used because after standardization of C++, IOStream became standard header whose function is now in std namespace. Unlike earlier when functions were defined in IOStream before standardization. Next is fstream. Fstream are associated with files. It is basically used to read the information from files and write the information in it. And next is iomanip. Iomanip is a library that is used in the manipulation of input and output statements. So these were some examples of header files. In this video,
we will be discussing about C++ array. So first is need of arrays. We use arrays because it allows us to store similar type of data within contiguous block of memory. And it allows us to iterate through those variables conveniently using indexing. Usually, an array is used to store similar kind of data like marks scored by all the students of a class and record of attendance of all the employees in an organization. Now moving to what is an array. An array can be defined as a collection of similar kind of elements. These are always stored in contiguous memory locations, that is one after the other. The total number of elements in an array is called the length of the array. Now this is the way you can visualize an array. Here each block is capable of storing data values of some type in sequential manner, and each element can uniquely identify by its index in the array. And this is the syntax of array. Int is the data type, array is the array name, and 5 is the size of array. Now there are few types of array in C++. Those are one-dimensional array, two-dimensional array, and multi-dimensional array. So let's first of all discuss 1D array. This is the simplest form of an array. In this array, data items are arranged linearly in one dimension, having single index value to represent data elements. Now this is the syntax of 1D array. Type is the data type, then there is array name, and after that size of array. And this is the example of one-dimensional array. Now coming to its memory representation. Here we can see 2, 7, 4, 8, 1, 6 are the elements inside the memory blocks. And 0, 1, 2, 3, 4, 5 are the indexes. So by using index, we can easily access the elements, and once the array elements are accessed, a number of operations can be performed. Here array of 0 means 2 and array of 1 means 7, and so on. As each element is of type int, that is 2 byte, that means the array occupies 12 contiguous bytes because each block contains 2 bytes and there are total 6 blocks. Now coming to the two-dimensional array. In this array, each element is referred by two indexes, that is rows and columns, and they are stored in the form of matrices. The first index shows a row of the matrix and the second index shows the column of the matrix. Now moving to its memory representation. As we can see, this is a 2D array with 3 rows and 3 columns. And we can also say that these are basically 3 1D array containing 3 blocks each, combined to form a 2D array in the form of a matrix with size of 3 cross 3. The horizontal lines depicts rows and the vertical lines depicts columns. And we know that index starts from 0, So first elements get stored at array 0 0, that is 0th row and 0 column. Then second element is stored at array 0 1, that is 0th row and column 1, and likewise all the elements are stored in the array. Now coming to the multi-dimensional array, these are defined as array of arrays. That means each element of multi-dimensional array is an array itself. They can have any number of dimensions and it stores the data in tabular form. A two-dimensional array is also a multi-dimensional array. And this is the syntax for a multi-dimensional array. Here, type is the data type of array, then array name is the name of the array, and size 1, size 2, up to so on size n are the dimension of sizes. After that, this is the basic example of a multi-dimensional array. Now, coming to the next topic, that is array initialization. So, there are two ways to initialize an array in C++. First is, you can initialize an array when you declare it by including the initial values in braces after the declaration. While declaring, we could use curly braces to set the values inside it. For example, in this array of size 6, the element 2 is at 0 index, 5 is at 1 index, 1 is at 2 index, and so on. If we don't mention the size of array, then the array will only be large enough to hold the elements added within the curly braces. Other than this, we can set the value after the declaration by assigning the element to the array using its index. Like array of 0 equal to 5, here we are assigning 5 to index 0, and array of 1 equal to 7, here we are assigning 7 to index 1, and same goes for the array of 2. Now let's do some examples on array to understand them better. We'll do these examples on our code editor, that is VS Code. Now we'll make a new file. Let's name that file as array.cpp, array1.cpp. Now we'll do a basic example in which we have to print the elements of array. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard, now we'll write int main. Now we'll start by writing the data type int. Now we'll write the array name, that is, let's say coupon, and now the size of array, let's say 6. Now curly braces. Now inside these curly braces we'll write those elements, let's say 5, 8, 7, 3, 9, 1. So these are those elements, and this is our array declaration. Now here int means the data type, coupon is the array name, 6 is the size of array, and 5, 8, 7, 3, 9, 1 are the elements of array. Now after that we'll write the for loop with for keyword. Now we'll initialize I with 0, I less than 6 because it is the size of array. Now we'll increment I. Now in this loop, all we have to do is to print this array. So how do we do that? So let's do cout and inside the bracket we'll write I. So here we have printed the array inside the loop and we have put I inside the array bracket. Now the loop will run from I0 to 6, and likewise all the elements from 5 to 1 will get printed. So let's see. Let's try to run this code. So this is our output, 5, 8, 7, 3, 9, 1. So this is how we can print the elements of an array. And if we want to print a particular element from the array, all we have to do is to write the index number of that element inside the bracket. Let's say if we want to print 7, all we have to do is to print its index number, that is 2. Now let's run this. See, 777. It is because of the loop that from I0 to I6. That is why it is getting printed 6 times. Now if we remove the loop and try to print it, then it will get print only one time. Let's see. Here 7. And this is what we want to print. Now let's do another example. Let's name this file array2.cpp. Now in this example, all we have to do is to do the sum of all the elements of the array. So let's start by writing our header file #include iostream. Now using namespace std, now we'll write int main. Now here first of all we'll declare a variable sum and initialize it with 0. Now we'll declare another variable n, and n will depict the size of the array. So first of all, in order to scan array, first of all we have to scan the size of it. So we'll scan n. Now we'll declare the array. And inside the bracket we will mention n because it is the size. Now we'll write for loop, and we will initialize with I equals 0, I less than n, which is the size of array, and we'll increment I plus plus. We are writing for loop here because we want to scan the array, and as in this array there are more than one element, so that is why we need for loops. So now we will scan the array. We'll write cin, then name of array, and inside the bracket we'll write I. Now here we have written I inside the brackets because we want to take input of elements from I equal to 0 to n, which is the size of array. Now we'll take another for loop. Now here we will write another for loop in which we are initializing I from 0 to n, and inside that for loop we will do the sum of the array. So we'll write equals to 0, I less than n, which is the size. Now we will increment I plus plus. Now inside this for loop we'll do the code, we'll do the logic of adding the elements of the array. We'll write sum. As we know that we have already initialized sum with 0, we'll write sum equals to sum plus array of I. Now for this statement sum equals to sum plus array of I, we are adding each value in the array one by one into the sum, which is initially 0. When I equals to 0, then the sum will be equal to 0 plus array of 0, and this sum will keep on getting stored inside the variable sum. As our I increments, our sum keeps on storing the addition value. Now we'll print this sum outside the loop. We'll write cout and we'll write sum is. Now we'll write the sum variable. Return 0. Let me tell you, return 0 is optional in C++. Basically, return value is exit status of the program and 0 is considered as OK. In C++, compiler includes it automatically, but it's a good practice. Here we forget to write the data type. Now we'll try to run it. So first of all, we'll write the size, like let's say 6. Now the elements of the array, let's say 1, 2, 3, 4, 5, and 6. Now we want to find the sum of these elements. Sum is 21. Let's recheck. 1 plus 2 equals to 3, 3 plus 3 equals 6, 6 plus 4 10, 10 plus 5 15, 15 and 6 is 21. So this is our right answer. So this is another basic example of array. So after this we'll do one example of two-dimensional array also. So let's make a new file and we'll write the header file. Let's name this file as array3.cpp. Now namespace standard. Now we'll write int main. Now we will declare a 2D array of 3 rows and 3 columns with elements inside it. Three rows, and in the second bracket we'll write 3 columns. Now we'll write the curly braces and another curly braces. This is the way to declare a 2D array. Now 2, 7, 9, let's say. Now again curly braces. 1, 3, 8. Because we are creating a matrix of 3 cross 3, that is why there are total 9 elements inside the array. So now we will create a nested for loop where the outer loop I, which is for the rows of matrix, is initialized from 0 to 2. We'll write int I equal to 0. Now I less than 3, I plus plus increment. Now we will write inner for loop j, which is for the column, and we will initialize it from 0 to 2 as well. We'll write for int j equals 0, j less than 3, j plus plus. Now we will print the array. In the first bracket we will mention I, that is the number of rows, and in the second bracket we will mention j, that is number of columns. And in order to add space, we will add space in the output. Now outside the bracket we will mention endl. Shift the elements to the next line. After that we'll write return 0. So this is our output 541279138 in the matrix form. That is why I have used this space to make the output look good, and this endl. So this is our output 541279138. So this is how we can print the elements of a multi-dimensional array or two-dimensional array. Moving on to what is a pointer. A pointer can be defined as a variable that contains the address of another variable. It basically stores the memory address, which means it points to an address of a particular value. And like a regular variable, pointers have a data type also. Now coming to reference and dereference operators. Reference operator or address of operator is defined as that operator which is used to get the address of the variable. It can be easily obtained by preceding the name of the variable with an ampersand sign. Now, dereference operator. Dereference operator basically returns the content stored in the variable pointed by the specified pointer. For example, if we write asterisk a, then it will return the value of variable pointed by a. Now, let's see how to declare and initialize a pointer. To declare a pointer, first of all, we will write the data type. After that, we will write the name of the variable with an asterisk sign. For example, int asterisk sign a, float asterisk b, char asterisk c. Suppose if we want to store the address into a pointer, then we will write int, that is the data type, then ptr, that is the name of the pointer, with an asterisk sign equals to a variable a with ampersand sign, which means ptr will contain the address of the variable a. Now, moving to a pointer arithmetic. C++ allows us to perform addition and subtraction operations on pointers. A pointer is basically an address, that is, it's a numeric value. Therefore, operations like addition, subtraction can easily be done on pointers. There are 4 types of arithmetic operations that can be used in pointers, that is, increment operator, decrement operator, addition, and subtraction. Each time a pointer is incremented by 1, it points to the memory location of the next element. But if the pointer is an integer pointer, its value on ptr++ would increment by 4 bytes because of the size of int data type. For example, assume an integer pointer with current value of 10. Now after the increment, its value would be 14 instead of 11 because int is of 4 bytes. Now let's learn about pointers and functions. Like a normal variable has an address, similarly every function has an address also. And we can easily access the function using its reference or address, only if we know the address of the function. Function pointers are similar to that of normal pointers. When pointers are passed to the function, the address of actual arguments in the calling function is copied into the formal arguments of the called function. And this is the syntax for a declaration of function pointer. Here int is the return type, and parentheses around function pointer tells the compiler that it is a pointer to function. And after this, they are argument lists. Now, let's discuss pointers and arrays. Arrays and pointers are very closely related to each other, and both of them are objects. When an array gets declared, the compiler assigns a continuous block of memory so that all the elements of an array can be stored in the memory. And C++ treats the name of the array as a pointer that contains the address of first element, which is known as base address. So basically, array name is the base address of the array. And if we have to assign the address of first element of array in a variable x, then instead of writing x equal to ampersand array of 0, we can simply write the name of the array only. Now, moving to the last topic, that is array of pointers. Like in array, we can store similar type of elements. It is same in case of array of pointers. But the only difference is, instead of storing the elements, the address of similar type of element is stored. In other words, it stores the pointers which point to the similar data type. And this is the syntax. First is data type, then name of array with an asterisk sign, then in the brackets it is the size of array. Now let's do some examples in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Here we will do one example of pointer to understand reference and dereference operator. We will print the values of variable and the address of that variable also, and it will give us an idea about reference and dereference operator. Let's start. First of all, we'll make a new file and name this file as pointer1.cpp. So first of all, we will import the header file #include iostream. Now we will include namespace standard. After that, we'll make int main. And now we will declare a variable val and assign it a value, let's say 105. Now we will declare a pointer variable ptr. Now we will store the address of the variable val into the pointer variable. So we will write ptr equals %val. Now we'll display a message. Before printing val variable, we'll display a message saying value of val is. Now let's see what is the value of ptr. For that we will have to print ptr also, and we'll write value of ptr is. Now we will print the pointer variable ptr also. Although the value of val and ptr would be same, but in order to check we will print that also. So we'll write cout value of specific ptr is. Now as we have printed variable val, ptr and asterisk ptr, so now let's check all these values. Let's first of all we'll write return 0. Now let's check all these values. Here we can see value of variable val is 105 and the value of ptr is this. This is actually the address, and the value of pointer variable ptr is 105. As we know that the value of val and the pointer variable is same because we have assigned this value, the address of variable val, to ptr, and then the dereference operator, as we know, returns the actual content of the variable. So that is why the value of variable val gets printed when we print the pointer variable ptr. And the address over here is the address of the val variable which we are assigning to the ptr. So that is why this address is getting printed. Now we'll do another example. Let's name it pointer2.cpp. Now we'll include the header files. Hash include iostream. After that, using namespace standard. So here we have an example of arithmetic operations in C++. So first of all, we'll write int main. Now here we will take 4 variables and 2 pointers. So let's do it. Int num1, num2, int sum equals 0, and int sub equals 0. We'll initialize it with 0. Now we will declare the pointers ptr1, ptr2. So let's take input of the required variables num1 and num2, and after that we'll do some arithmetic operations on them. So let's just write. First we'll display a message. Enter 2 numbers. Enter 2 numbers. Now we'll take the input. After this, we will store the address of num1 and num2 into ptr1 and ptr2 respectively. So let's do it. ptr1 ampersand num1, ptr2 ampersand num2. Now we will increment pointer ptr1 and ptr2. We'll do in a bracket, and we'll use dereference operator also. ptr1 plus plus dereference operator ptr2 plus plus. Here we are using dereference operator because we want to increment the value only. And as we can see, we have used increment operator. So by incrementing ptr1 and ptr2, the values of num1 and num2 will increment, and after that we will print those values. So let's do it. Before printing, we'll just print a message after increment. Now we will print ptr1 and line. Now ptr2. Now we will do the sum of these incremented values. So we will write sum equals dereference operator ptr1 plus dereference operator ptr2. Now we will simply print it. We'll write addition and we'll print some variable which we have already initialized as 0 earlier, and we'll write endline. So this will give us the sum of the incremented values of num1 and num2. Now let's talk about decrementing the value of pointers using decrement operator. Here by using this operator, the value of the ptr1 and ptr2 gets decremented. So let's start. We'll write decrement ptr1 minus minus. That is the decrement operator. Now ptr2 minus minus. Now we will write after decrement the values of ptr1 and ptr2. So we'll display a message saying after decrement now we will print ptr1 and ptr2. This will display the values of ptr1 and ptr2 after decrement. And at last we will find the subtraction of 2. So we'll write sub decrement operator ptr1 minus decrement operator ptr2, and cout will display first subtraction. We'll write subtraction, then we'll write the variable sub. Let's see how it. Before that, I think we forgot to mention the dereference operator while printing. We have to mention this because we want to print the values. Dereference operator. And let's put some space over here. Now let's try. Enter two numbers. So let's say we'll enter 4 and 5. As you can see, we have entered 4 and 5. After increment, it becomes 5 and 6. And on addition, it becomes 11. After decrement, it becomes 4 and 5 again. Then 4 minus 5, that is equal to minus 1. So this is the right answer. And this is how it's done. This was the basic example of arithmetic operations in pointers. Now let's do another example. Name this file as pointer3.cpp. Now we will include the header files hash include iostream using namespace standard. Now we'll write int main. Now we will do an example of pointer and arrays in which all we have to do is to print an array with the help of pointers. So let's start. First of all, we'll declare a pointer. Now we'll declare an array named rray. And let's add some elements inside it. 5, 17, 20, 7, 9, 4, 6. I think these are 7 elements. Now we will assign array arr to pointer ptr. So we'll write ptr equals arr. After that, we'll run a loop from I equal to 0 to I less than 7 because we want to iterate array elements. So let's write for loop int I equals 0, I less than 7, I plus plus. Now we'll display using dereference operator with pointer because we want to display the values, that is why we have used dereference operator. Now we'll do ptr plus plus. We have used ptr plus plus because we want the pointer to move to the next position after each iteration, and endl will help to print the output in the next line after each iteration. So after this, we'll write return 0. and let's try to run it. I think there is some error. Yeah, namespace. Now let's again try to run it. Instead of array we have used ARR. Hope it works now. Here it is. 27946. 51727,946. So these are our array elements which we want to print. So this is how we can print the array elements with the help of pointer. So these were some basic examples of pointers in C++.
Let's go ahead and have a look at what is memory management. Memory management can be defined as a process in which management of a computer's memory occurs. For example, assigning memory to programs, variables, etc. in such a way that it doesn't affect the overall performance. Sometimes the computer's data can range up to terabytes. So efficient use of memory is necessary so that we can minimize the memory wastage and boost up the performance. Now, let's understand why we need memory management in C++. Memory management is required so that there will be no wastage of memory, and to make sure that allocation takes place efficiently. During the declaration of an array, there are times when the correct memory is not determined until runtime. And to avoid such cases, we usually declare array of maximum size. And because of this maximum size, some memory remains unused. For example, let us suppose we have declared an array of size 30. And after declaring the array, it turns out that we only need space of 10 size. So the rest of the space is of no use, or we can say it will get wasted. To avoid such cases, we use memory allocation. So let's understand memory allocation and deallocation in C++. Other programming languages like Java, Python, etc., they don't need to allocate memory dynamically. In C language, we use the malloc or calloc functions to allocate the memory dynamically at runtime. And these functions are also supported by C++. But in C++, allocation and deallocation is done manually. In C++, there are two operators that are used for the allocation and deallocation of memory. That is new operator and delete operator. So let's understand this new operator in C++. The new operator in C++ is used for the dynamic memory allocation. It is used to allocate the memory at runtime. The general syntax of new operator is pointer variable, which is the name of the pointer, equal to new, which is a keyword, and data type is the type of the pointer. The syntax for arrays is almost the same, but after the data type, we have to write the size inside the brackets, which specifies the number of elements in an array. And here in the example, we first of all are declaring a pointer ptr of int data type. After that, we are dynamically allocating the memory using new keyword, and at last we are assigning the value 75 to the allocated memory. Coming to the delete operator. The delete operator in C++ is used for the deallocation of memory. When we no longer need to use the variable, that means the memory is no longer required, then we have to deallocate or release the memory using the delete operator. Syntax for delete operator is delete keyword with the name of the pointer variable. The syntax for arrays is delete keyword following the empty brackets and then name of pointer variable. As we can see in the example, once the printing of value is done, we have deallocated the memory using the delete operator. Moving on to the advantages of new operator. The new operator and delete operator can be overloaded unlike the malloc function. Next is, return type of the new operator is of the same type for which the memory was allocated. We don't need to use the typecasting. Third is the new operator automatically computes the size of data object. We don't need to use the size of operator. Next is new operator in C++ allows us to initialize object while creating memory space for them. So these were some advantages of the new operator. So now let's move on to our code editor, that is VS Code, to do some examples on the new operator and delete operator. Here we will do an example using new and delete operator in C++ that will allocate the memory location for 3 values and find their average. So first of all, let's create a file and name this file as mm1.cpp. mm means memory management. So now first of all we'll include the header files, #include iostream, now using namespace standard, now we'll start with int main. Okay, so first of all we'll create 3 pointer variables. So we'll start int star ptr1, int star ptr2. We are creating 3 pointer variables because we have to find the sum of 3 variables, so that is why we have to create 3 pointers also. And now we have to store the sum of 3 variables into some another variable, so now we'll create the variable average. Okay, now we will allocate the memory dynamically using the new keyword. So we'll write ptr1 equals new int, which is the data type. Same we will do for ptr2 equals new keyword int. Here we are allocating the memory dynamically with the help of new keyword, new int. Sorry, m is there. Now we will print the value that is stored in the memory. But before doing that, as we have allocated the memory, so now we will take the input from the users of those 3 variables of which we have to find the average of. So we'll display enter first number. After displaying this, we'll take the input from the user, we'll write cin, and using the dereference operator, we'll write ptr1. Here we are taking the input from the user for the first memory location. Now we'll take the input of the second number from the user. For that we have to print the message again. Enter the second number. Yeah. Now we'll take the input using the dereference operator with the pointer. Now same goes for the third one. Enter the third number. Dereference operator ptr3. As we have taken all the 3 numbers from the user, Now all we have to do is to find the average of these three numbers, as we know that dereference operator will point to the variable. So that is how we'll get the access for the variable. Now we'll write the variable avg, that is average. We know that dereference operator will display the value that is pointer pointing at. So we are actually adding the values ptr1 plus dereference operator ptr2 plus dereference operator ptr3 divided by 3. This is how we can find the average. After that, all we have to do is to print the average. So we'll write average is avg, that is the variable, as the result is getting stored in this variable avg. So we'll print that variable, and once everything is done, once the printing is, then we have to deallocate the memory, and we will deallocate the memory by writing delete ptr1. We have to do this for all of these three pointers. Delete ptr2, because we have allocated the memory for all of these three pointers, so that is why we have to deallocate for each one of them. Okay, now everything is done, and let's try to run this. Here we can see enter the first number. So let's say 5. We have to find the average of three numbers, so we'll select the easy number to check whether it is right or wrong. Then we'll write 5 again. Now we'll write 2. As we know that 5 plus 5 equals 10 plus 2 equals 12, and the average of 12 is 4. Yeah, 3 4s are 12. So this is the correct output. So first of all, we have allocated the memory over here dynamically. Then we have deallocated the memory using delete ptr1, ptr2 and ptr3. So this is how it's done. So let's do one another example. Let's name this as mm2.cpp. Okay. We'll write mm4.cpp. I think 2 and 3 are already taken. So we'll start with hash include iostream. Hash include iostream. Then we'll write using namespace standard. So in this question, we'll simply enter the elements of the array, and then we will display those elements. But we will use new operator and delete operator in this question. So let's start. First of all, we'll write int main. Now inside int main, first of all, we'll write the variable size. We have declared the variable size, and this variable size is the size of the array which we will take as an input from the user. So first of all, we'll display enter the size. Enter the size. Now we'll take the input size. After that, we will declare a pointer variable ptr. Alright, now here we will allocate the memory for the complete array. So we'll write ptr new keyword int, which is the data type, and here size. Okay, here we are allocating the memory for the complete array of size that we will enter. Okay, now we will display the message saying that enter the elements. as we have allocated the memory. Now all we have to do is to enter the elements. We'll use a for loop. So we'll start with int I equals 0, I less than size, I plus plus. Now we'll write element, and after this we'll take the input from the user for the elements of the array. So we'll write cin. Now just like arrays, we can do it for the pointer as well. We can write ptr, and just like arrays, inside the bracket I, and we can do it for the output as well. So here we are taking the input of the elements from the users. Now we have to display those elements. So for that, first of all, we'll display a message, elements that you have entered. Now we'll use for loop again. Int I equals 0, I less than size, I plus plus. Now we'll print those elements. So first of all, we'll write element now ptr, like just we did earlier, ptri, and end line, so that the output looks good. Now everything is done. We have allocated the memory, then we have taken the input from the user and displayed the output. Now all we have to do is to delete the operator. So we'll write delete, then empty brackets, ptr. Alright, now everything is done. We have allocated the memory, and here we are deleting the allocated memory. Okay, now let's try to run this. Here we can see enter the size, let's say 4. Now enter the elements 3, 6, 5, 7, and here is the output, elements that you have entered 3, 6, 5, 7. That is right, but it is not looking good. Let's use /n over here, and now let's again try to run this. Enter the size 4. Now 2, 4, 7, 9. Here is the space between them. Now it is looking good. Enter elements that you have entered are 2, 4, 7, 9. So this is how it's done. We have allocated the memory to an array of size variable. Then we have entered the elements. Then we have displayed those elements, and at last we have deallocated the memory using delete operator. So these were few examples on memory management, C++ memory management. You can try some more examples on them. Let's go ahead and have a look at why do we need classes. To understand this, we need to know that C++ is an object-oriented language, and it also introduces the concept of real-world entities. So in order to describe the real-world entities, we need two things, that is characteristics and functions. And a class is a mechanism of binding these two methods together in a single unit. Also, class has its own members like functions, variables, constructors, destructors, etc., which are commonly used in C++. and class has an important role in the concept of inheritance as well. Now, let's understand what is a class. Classes are one of the most important features of C++ that leads to object-oriented programming. It represents the set of properties that are common among all the objects of same type. A class basically represents a group of similar objects which holds its own data members and member function together. And this is the basic syntax of a class. First is class keyword, which is used to create class. Then after that we will write the name of the class. Then inside the name of the class there is access specifier that can be private, public or protected. After that there is data members, that is the variables, and then the member functions, and also class body must be surrounded with braces. Now let's discuss access modifiers. It basically grants permission or set the restriction for data members of the class. Access modifiers in a class are used to provide accessibility to the class member. For example, in a school, teachers are allowed to see the question papers before the exams, but the students are not allowed to do so. Anyone other than teachers cannot access those questions. Now, we can relate these teachers to data members of class which have access, and students are outside functions that do not have the access. So there are three types of access modifiers: private, public and protected. Private members can only be accessed from within the class. That means outside data members and member functions cannot access it. Public, as the name suggests, it can be accessed from within the class and from outside the class as well. Protected members can be accessed from within the class but cannot be accessed from outside the class. But with the help of friend function, it can be accessed from outside the class as well. Now let's learn about object of a class. An object is an instance of a class. It is a real-world entity that contains state and behavior. When we create an object of a class, then the memory is allocated and no memory allocation occurs when class is defined. And we can create as many objects of a class as we need. In this example, state is the class and st is the object name or reference variable. So this is how an object is created. Now coming to member functions. Member functions are also known as methods. These are as much as part of the class as the member variables. These member functions can be invoked by sending messages through an instance of a class with the help of dot operator. For example, if the name of the object is obj and we want to access a function named sum, then it will be obj.sum. Here obj is the name of the object and sum is the name of the function. Now let's learn about constructors. Constructors can be defined as a special type of method that is invoked automatically whenever an object is created. Its main use is to initialize objects. It doesn't have any return type and a constructor has the same name as that of the class. And it is of two types, parameterized and non-parameterized. The syntax for parameterized constructor is class name, which is a constructor name, and then arguments inside the bracket. In non-parameterized constructor, the syntax is class name with empty brackets, as there are no parameters in non-parameterized constructors. Now, after constructor, let's discuss the destructor also. Destructor, as the name suggests, is also a special method that destroys or destructs the object as soon as the scope of the object ends. And it is automatically invoked when the object goes out of the scope. Its name is same as that of the class, but with the tilde sign. Here is the syntax of destructor: tilde sign with constructor name or class name and then empty brackets. Now to do some examples on classes, let's move on to our code editor, that is VS Code. Now here we will make a new file and let's name this file as class.cpp. Now here we will do a program in which we will make a class, and inside that class we will make some functions, and with the help of objects of that class we will call those functions. So let's start. First of all, we'll mention the header files #include iostream. Now using namespace standard. Now let's make a class, and with a class keyword, and name this class as, let's say, franchise. Now here don't forget to mention the semicolon. Now here we will write the access modifier, that is public Now we'll mention those functions. Let's say void, let's name this function as KFC. Now inside this function we will print something like, let's say, we have the best chicken. After this we'll write endl. Now we'll make another function named Burger King. As we know that these two are famous franchise, so that is why we have put this under class for franchise. Now let's print here we have the best burgers. Now we'll try to print these two functions with the help of objects that are made from the class franchise. So what we'll do is we'll write int main. After the franchise class we'll write int main, and inside this class we'll make an object of class franchise. Franchise is the class name, fran is the object name. Now all we have to do is the calling. We'll call the function KFC and we'll call the function Burger King with the help of fran object. So let's do this. Fran dot operator KFC, that is the function name. After that we'll write fran dot Burger King, return 0. Now let's try to run this one. Here it is. Actually I have run it twice, so that is why it is getting printed twice. We have the best chicken, we have the best burgers, that is what we want to print. First here friend.kfc, call this void KFC inside this class franchise. After that friend.burgerking, call this function Burger King. So that is why they have printed serial wise. We have the best chicken, we have the best burgers. After this we'll do another example. So let's do this. First of all we'll name this file class2.cpp. Okay, I think it already exists. We have to name it something else. 3. Okay, now we will write the header files. Hash include iostream. Now using namespace standard. In this example, we will try to access a private variable, as we know that it can only be accessed from within the class, but it can be done with the help of setter-getter methods. So let's start. First of all, we'll write int main. Now we'll make an object. For that we have to write the class name, which is billboard. We'll make this class afterwards. First of all, we'll write the class name. After that we'll write object. Let's name the object bill. Billboard is class name, bill is the object name. Now we will call a particular method or a function which we call setter method. So we'll write bill dot, we'll name that setter method as set title. Basically this function will access or assign the value to the private variable which we were talking about. So we'll write here, let's say top 5 songs of 2020. We want this title to be written on the billboard. Now we'll write the getter method. Basically the setter method or set title method will set or assign the value of to the private variable, and get method or get title method will return that value from there. So we'll write bill dot get title. Now because we want to print it, so that is why we'll write it in cout. Okay, now after that we'll write return 0. Now we will make the class billboard. Class keyword billboard. After that bracket starts. Now we will write private because we want the variable to private. So the data type string and the variable is title. Now this variable is private and we want to assign the value to this variable, which is not possible because they are not of the same class, but we will do that with the help of setter-getter method. So let's do that. Now we will write public because we want our functions to be public. Now void, that is the data type, set title, and inside the bracket we will write the variable. Now this method is taking this parameter x, so we will assign this parameter x to the private variable. Let's do that. Title, that is the private variable, x. Now we will write another method named getTitle. There are no parentheses in getTitle method because this method is only returning the value. So we'll write return title. Now getTitle function or method is returning the value of private variable title. So here what happening is, here the function setTitle, which is public, is taking a parameter x and is assigning to the title variable.
So the message will get assigned to the title variable. Now getTitle function is returning the value of private variable title, which is getting called in the main function. One more thing, we forgot to put semicolon over here, and getTitle cannot be void because it is returning. It would be string because it is returning some value. Now, so basically build.setTitle in the main function will set the value or assign the value to the private variable, and build.getTitle will return the value of that private variable, which will get printed. So now let's try to run this. Top 5 songs of 2020. Here we can see it is getting printed. So this is how we can do that. We can access the private variable using setter and getter method. Now let's do another example. Let's name this as class 4.cpp. Now here we will do the same example, but we will do it with the help of constructors. So let's continue. First of all, we'll write hash include iostream. After that, using namespace standard. Now here first of all we'll write int main. Now we'll name the class, we'll write the name of the class, that is billboard, and we'll make the object of it as we have done previously, like bill. Now we'll make a constructor of this object and we'll pass the parameters. We'll pass the string as top 3 songs of 2020. As we are passing this string to the constructor, that means the constructor is parameterized constructor. And now we'll write bill.getTitle. Here we are writing this because this function is returning the value of private variable title. So that is why we have to write it. And we'll print it actually cout. Return 0. Now let's do the other thing. As we have done previously, we'll write class billboard. We are making this class, and inside this class we are making the variable private. String title is private. Now we'll write public access modifier. Now here we will write the constructor in which we were passing the string from the main function. So we'll write the name of the constructor. As we all know, the name of the constructor is same as that of the class, so it would be billboard, and the parameter is b. That parameters which we are passing from the main function is getting stored in b. Now inside this constructor we'll call the method setTitle. So we'll write setTitle. We are passing the same string to the setTitle method. Now
we'll make this method setTitle. We'll write void setTitle string A. So actually what is happening, we have passed a string named top 3 songs of 2020 to the constructor. The constructor is further calling to the method or function named setTitle and is passing that string to the same function. Now that function is setTitle, and now we will assign that string to the private variable title. So let's write title equals A. A is that string. Now, as we have done previously, we'll write void get title. Now get title function is used for returning the value of private variable, as we know. So we'll write string actually. String get title return title. Semicolon. Now let's try to run it. I think something is wrong. Here capital S we have written. Let's make it correct. Now let's try to run again. Here we can see top 3 songs of 2020. So this is how we can print with the help of constructor. This was the same example as that of the previous one, but to understand constructors we have done this with the help of constructors and we get the right output. So after this we'll do the example of destructors. Okay, let's name this as class 6.cpp. Now let's write the header files. Hash include iostream using namespace standard. Now we'll start with int main. So first of all we will write the class name, that is Gambit. To access the class we need to have an instance or object of class. Here the name of the object is Gam. After this we will call a function display, so we will write gam.display. Return 0. Now let me tell you what is happening. So as we declared this object, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So after this we will write the class. Let's make it class keyword Gambit. Now we'll write public access modifier. Now we'll write the constructor and inside the constructor we'll display the message. We'll write hello there, I'm a constructor, I'm in constructor. Now here we will write the destructor. Gambit, and inside the destructor we will print the message just to indicate that we are in the destructor. Hello there, I am in destructor. Semicolon. But before that we have to write the function display also. So we'll write void display, and we'll print the message, let's say hello. And L. Now let's try to understand this again. As the object is declared, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So hello will be printed. Now as we can see, the program has finished the execution. Now the destructor will be called and hello I am destructor will be printed. As we know, destructor destroys the object as the scope of the object ends. So after the scope of the object ends, hello I am in destructor gets printed in the last. So now let's try to run this. Here we can see hello there I am in constructor, then hello is printed, then hello there I am in destructor is printed. As we have thought, destructor is getting printed in the last because as we know that when the scope ends, the destructor is called. So these were some basic examples of classes in C++. Now let's move on to why oops. Well, there were some limitations in earlier approaches to programming, and oops help to fill those gaps. In object-oriented programming, it is easy to maintain the code with the help of classes and objects. And with the help of inheritance, there is code reusability. That is, we don't have to write the same code again and again, which increases the simplicity of the program. Now, let's understand what is object-oriented programming. Object-oriented programming is a programming pattern where the programs are structured around objects rather than logic and functions. In other words, we basically focus on objects that are required to be manipulated instead of logic. For example, let us suppose we have made blueprint of a mall, then that blueprint will be a plan that explains what properties the mall should have and how it should look like, etc. But it is just a blueprint of the mall. We cannot go inside it physically as of now. Now the constructors will go through the blueprint and they will construct the mall, and they can make as many malls as they want with the help of that blueprint, and each mall can have its own different shops and showrooms. In this case, blueprint is the class, the mall is the object, and the shops and showrooms inside the malls are data stored in the object's properties. And these are some basic concepts of OOPS. First is classes, then objects, then data abstraction and encapsulation, then there is inheritance, polymorphism, dynamic binding, and message passing. We will learn about these concepts later. First, we will discuss the difference between OOPS versus procedural programming. Procedural programming follows top-down approach. Here, top-down approach means fragmenting a bigger complication into smaller chunks. OOPS follows bottom-up approach, and bottom-up approach means piecing together smaller tasks to give rise to complex tasks. In procedural programming, overloading is not possible. In OOPS, overloading can be done. In procedural-oriented programming, there are no access specifiers. In OOP, they have access specifiers like private, protected, public. Procedural-oriented programming is less secure. OOPS is more secure because of the concepts like abstraction and encapsulation, which are used for data hiding. Now, let's learn the basic concepts of OOPS. First is class. Class can be defined as collection of objects. It is a logical entity. Then there is object. It is defined as an entity that has state and behavior, or in other words, anything that exists physically in the world is called an object. Inheritance can be defined as when one object acquires properties and behavior from its parent class. It provides code usability. Polymorphism. Polymorphism is a combination of two words, poly, which means many, and morphs, which means forms. It is basically an ability to exist in more than one form. Next is abstraction. Hiding the internal details and showing the functionality to the user is called abstraction. Then encapsulation. Encapsulation is the binding of code and data together into a single unit. Dynamic binding. Dynamic binding is the method call at runtime that means which code will execute is unknown until the program runs. Then there is message passing. It is basically a communication that exists between the objects. As we have gone through some concepts of OOPS, now let's discuss some benefits of OOPS. In OOPS, code can easily be reused with the help of inheritance and object. We don't need to write the same code over and over. Second is, with the help of abstraction and encapsulation, certain parts of program can be hidden, and it helps to make a secure system. Third is, maintaining and modification of code is easy in object-oriented programming. Now, to do some examples on the concepts of OOPS, let's move on to a code editor, that is VS Code. Now here we will do a program of inheritance in which we will make a parent class and a child class, and we will call the attributes using object of child class. So let's get started. First of all, let's name the file. oop.cpp. Okay, so first of all we'll add the header files #include iostream. Now adding namespace standard. Now we will write int main. So we want to create the object of child class. So first of all we'll write the name of class child, that is child. Let's put C capital, child, and now the name of the object ch. So now we will call the attributes using this object. So we'll write first of all display it. So we'll write cout ch dot name 1, which is the attribute. We will declare it later. So basically we want to write both the names of both the classes together, so that is why we are doing like this. We'll write name2. Name1 will be the attribute of the parent class and name2 will be the attribute of child class. So after that we'll write return 0. Now we'll make the parent class and the child class. So first of all, let's write class parent. We'll name it as parent. Then we'll write public access specifier. String is the data type. Name 1. Let's write Harley. Okay, now it is mandatory to write the semicolon at the end of the class. Now we'll write the derived class, that is child. We will write the colon symbol. Then we will write public name of the parent class, that is parent. So here we are writing the child class is derived from the parent class. Now within the bracket we'll write public, then string, the data type, name 2. We'll write Davidson. It's a popular bike brand, Harley Davidson. So now we'll write the semicolon over here. Now we'll try to run this. As we can see, Harley Davidson. Here Harley is from the parent class and Davidson is from the child class. So as we can see that we are calling from the object of child class and still we are able to access the attribute of parent class. So this shows that the child class inherits attributes or properties from the parent class. Now as we have done one example of inheritance, so now let's do one example of polymorphism also. Let's name it oop1.cpp. First of all, we'll include the header files. --include iostream stream. Now we'll write using namespace standard. After that we'll write int main. Now here we will do an example of polymorphism in which we will make a base class and its derived classes, and inside these classes we will override a function which is common in all of these classes. So let's start. First of all, we'll write the name of the parent class or base class, animal, and we'll make an object A. After that we'll write the name of the child class cheetah and its object name is seal, let's say. Now another derived class dolphin, and we'll name the object as D. Now while making these classes we'll write a function named speed in all of these classes, inside all of these classes, and now in order to override that function we'll call them. So first of all we'll call it by the object of animal, that is a dot speed. Now c dot speed, this is the object of cheetah class. Now d dot speed. After that we'll write return 0. Now let's make these classes. First of all we'll make the animal class, that is the base class. Animal. Now we'll write the access specifier public Now we'll write the function void, that is the data type speed. Now we will display a message inside this function. Let's say it displays who is more faster. Who is more faster. Okay, now we'll put a semicolon in the end. Now we will make a derived class, that is dolphin. We'll write class dolphin child of animal class. Okay, so now inside this class we'll write public and we'll make the same function speed. And we'll display a message saying, as this class is of dolphin, so we'll write I'm faster in water. We'll put semicolon. Now we'll make another child class, class cheetah. Okay, C is capital, cheetah. Public animal. Now here we will write public access specifier and we'll write the same function void speed. And over here we'll display a message saying that I am faster on the ground. Semicolon. So now as we can see that a.speed is calling this speed function in animal class, c.speed is calling this cheetah function in cheetah class, and d.speed is calling the dolphin speed function in dolphin class. Okay, so now let's try to run this. Okay, the output is here, but it is not in very good form, so let's put /n in the end. Okay, /n. /n. Okay. Here it is. So first who is faster is displayed, then I'm faster on the ground, then I'm faster in water is displayed. So as we know that first of all we have called the animal class, so that is why who is more faster is displayed. After that we have called the cheetah class and cheetah says that I'm faster on the ground. Then dolphin class, then dolphin says I am faster in water. So here we can see that each of the class have its different implementation for the same function, that is speed, and this is how polymorphism allows us to do a single action in variety of ways. Okay, now let's do one example of abstraction. Let's name it as OOP 3.cpp. First of all, we'll include the header files. We'll write hash include iostream. Now we'll write the namespace standard using namespace std. Now, as we know, abstraction helps in data hiding. So in this program, we will make a variable named coupon as private, and with the help of setCoupon function, we will try to assign some value to the coupon variable, and after that we will display it. So let's start. First of all, we'll write int main. Now we'll write the name of the class, that is trade fair, and now the name of the object t. Now with the help of this object, we will call a function named setCoupon. I would say coupons, and we will pass 50 as an argument to this function. Now we'll display a message coupon, and after that we will call getCoupon method in order to display the number of coupons. So we'll write t dot get coupons and brackets, done. After that we'll write return 0. Now let's make the class and the functions. So let's start. First of all, we'll write class trade fair. Now we'll write an access specifier private and private. Now we will declare a variable coupon, and as I've already told you, we will make this variable as private, so that is why we have used this access specifier as private. Now after that we will write public access specifier to write a function that is setCoupons. And the parameter is c. As we know that we have passed 50 to this parameter, so now we will write the private variable coupon equals c. So here we are basically assigning the value of c to the coupon, that is we are assigning 50 to coupon variable. Now after that we will make another function and we'll put its data type as int because it is returning something. So we'll write int get coupon and we will return variable coupon. Now as the class ends, we will write semicolon. Now let's try to run this code. There is some error. Okay, we haven't write s over here. Now let's again try to run it. Coupon 50, as I've told you. So here we have assigned 50 to this function and the variable c is assigning 50 to the variable coupon. Now after that we have used getCoupon function to return the value of coupon, and that is why it is getting displayed over here. So we got our answer, that is coupon 50. And as you can see that in this example we are not allowed to access the variable coupon, but still somehow we have managed to do that with the help of some functions. So this is an example of abstraction, and it helps to increase the security of the program. So these were some basic examples of OOPS in C++. Let's go ahead and have a look at what is operator overloading. Operator overloading is a special case of polymorphism in which the operator is overloaded to provide special meaning to the user-defined data type. Basically, it adds some features or redefines the functionality of already existing operators. For example, let us suppose we have three objects of same class, namely A, B, C, and C equals A minus B. Now here we can redefine how minus operator works, and we can write C equals A minus B instead of writing C equals to A dot subtract B. And this is the general syntax of operator overloading. First is the return type of the function. After that, operator is the keyword, then symbol is the operator we want to overload, then the arguments are those which are passed to the function. Now let's move on to the non-overloadable operators. There are some operators in C++ that cannot be overloaded because it is not syntactically possible to overload them. First is the dot operator, then next is scope resolution operator, and third is pointer to member operator, and at last we have ternary operator. Coming to the next topic, that is types of operator overloading in C++. So there are two types of operator overloading, that is unary operator overloading and binary operator overloading. First is unary operator overloading. It is defined as an operator which contains only one operand or works on only one operand. Increment operator and decrement operator are examples of it. There are two ways to do operator overloading, that is from the class function and the friend function. Its syntax using class function is the return type, operator keyword, then the symbol and the brackets. But if we are doing postfix in the function, then we have to write the data type inside the brackets. Syntax using friend function is friend keyword, return type, then operator keyword, after that symbol, and in case of friend function we have to pass an argument. Next is binary operator overloading. An operator which contains two operands or works with two operands is called binary operator overloading. Addition, subtraction, multiplication are examples of binary operator overloading. Syntax using class function is return type, then operator keyword, then the symbol, and then we have to pass an argument inside the brackets. And syntax using friend function is friend keyword, then the return type, after that operator keyword, and then the symbol, and in case of friend function we can pass two arguments. Now we will do one example of unary operator overloading in which we will increment the value of the variable with the help of operator overloading. So now let's move on to our code editor, that is VS Code. So here first of all we'll make a new file and name that file as operator.cpp. Now first of all we'll write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with int main, and inside int main first of all we'll write the name of the class, that is increase, and its object inc. Now we will call the void operator increment function. So we will write ++inc. Here when we write ++inc, then function void operator ++ will be called, which we will make later. So as of now, first of all we write inc.display in order to display the output. We are calling the display function over here. Now after that we'll write return 0. Now we'll make the class. So we'll write class increase, which is the name of the class. Now we'll use the access specifier private and we'll write the variable int value. Now we'll write another access specifier public, and now we will make the constructor because we have created the object inc, so that is why a constructor is called, and we are making it increase. And inside the constructor we have given the value 10 to the variable. Now ++inc is calling the void operator ++ function, so we'll write that function void operator increment, which is the symbol. Now value equals value plus 5 because we are incrementing the variable with 5, so we'll write value equals value plus 5. Now after that we have to display the value variable, so we will write void display because we have already called over here inc.display. So now we will write inside cout, we'll write the message value is now the variable value and endl. After the class we have to use the semicolon. Now let's try to run this. Here is our output. Value is 15. Previously the value was 10, then on increment its value gets 15, which is the right output. So here first of all we have created an object and constructor is called, and inside the constructor we have initialized value with 10. Then with the help of object inc, that is when we are using ++inc, then we are calling the void operator function, which is increasing the value of the variable by 5, and then we are displaying it with the help of display function. And one more thing guys, in case of postfix, that is in case of inc++, we have to write the data type inside the void operator function, that is over here. Now let's do another example for binary operator overloading. So let's name this operator 2.cpp. Now here we will do one example of binary operator overloading in which we will add two complex numbers. So let's start. First of all, let's make the header files #include iostream. Now using namespace standard, now we'll write int main. Okay, now first of all we will write the name of the class, that is complex. So we'll write complex, and then the objects like com1, com2, res. We have created 3 objects. Now we will write a message because we have to take the input from the user. So first of all we will write a message enter first complex number, because we have to add two complex numbers. So first of all we'll take the input of the first one, that is /n. Okay, now we have to write com1 dot input. Input is the name of the function which we will be creating afterwards. Then cout enter second complex number. That is, now we'll write /n. Okay, now after this we have to write the semicolon and we'll write com2 dot input. These input function will take the input of complex numbers from the user. We will declare them later, we will make them later. Okay, now here we will do an operation with the help of plus operator function. So we will write res equals com1 plus com2. This function call from com1 will go to the complex of operator plus function, and com2 will be passed to the argument obj, and the result will be stored in variable res. Okay, now we will call another function output in order to display the output. Res.output. After that we'll write return 0. Now we will make the class complex. We'll write class complex. We'll write the access specifier private and the variables int real and int imag, that is imaginary, because we know in complex number there is a real part and imaginary part. Okay, now we'll write public access specifier, and now we will write the function input. In order to take the input from the user, void input. Now first of all we have to display a message. We will write enter real and imaginary parts respectively. Okay, now we will write cin, because we have to take the input, and the variable name real and imaginary. Now we will write the overloading function. We'll write the return type, that is the complex, then operator keyword, then symbol, then argument, complex obj. Okay, now we will write complex temp. So here we have created the data type temp of complex class. We'll make it a capital C. Okay, now we will write temp.real equals to real plus obj.real. So we'll write temp.real real equals to real plus obj dot real. The plus operator over here will add the real part of the number to the real part of another number. And similarly we'll do it for the imaginary part. We'll write temp dot imaginary equals imaginary plus obj dot imaginary, and then the value of the variable temp is returned. So we'll write return temp. The value was stored in temp, so that is why we have returned temp. Now we will make the output function. We'll write void output. We'll write output is variable real, then we'll write plus, then imaginary, and then I, because this is the syntax for complex number. Okay, now we have to put the semicolon over here. As the value of temp is returned, now the result is stored in variable res, and then we will print the output using the output function. This is the output function, and the value is stored in res, and then we are printing the output using the output function. Com1 over here is getting passed to the complex of operator plus function, and com2 is getting passed to the argument obj, and the result is getting stored in res. Now let's try to run this code. The first complex number, let's say 2 plus 2 iota, so we will write 2 and 2, and then enter second complex number, that is enter real and imaginary parts respectively. Now we have to write the real and imaginary parts of the second complex number, so we'll write 4 plus 6 iota. So the output is 6 plus 8 iota. 2 plus 4 equals 6 and 2 plus 6 equals to 8. So this is our correct output. We are basically adding two complex numbers with the help of binary operator overloading. So this is how it is done. So these were some important examples of operator overloading.
Moving on to
why we use vectors in C++. Vectors are used when we are not sure about the size of data. Like in case of arrays, we have to guess the size of the data first because it is not possible to resize it later. But in case of vectors, we don't have to set the size of vector and it is resizable. That is why it is more preferable for dynamic elements. And it also has some inbuilt functions like pushback, size, empty, etc., which helps in dealing with data values. Now let's understand what is a vector. Vectors are array-like containers that is used to store data, and the data is stored in contiguous storage locations. But unlike arrays, its size can be changed automatically depending on the number of elements, and it is not necessary to mention the size of vector while declaring it. Now let's have a look at the syntax here. Inside the angle brackets, this is the data type of the vector. It can be string, int, float, etc. and v2, v1, v3 are the names of the vectors respectively. Now let's understand the member functions of vectors. A vector container has three types of member functions, that is modifiers, iterators, and capacity. So let's understand these functions in detail. First is modifiers. These are those functions that are used to modify data elements. For example, first is pushback function. This function is used to add a new element to the end of the vector. Next is popback. This function deletes the last element of the vector. Then there is insert function. It is used to insert a new element at a specified position. In this function there are two parameters. First parameter specifies the position and second specifies the value. After that, erase function. Erase function is used to remove the elements at a certain position or to remove a range of elements. Either you can write the position of the element you want to remove inside the bracket, or you can write starting position and ending position of the range of elements inside it. Next is swap function. This function is used to swap the contents or elements between two vectors. And if there are two vectors named v1 and v2 that we want to swap, then its syntax would be v1.swap v2. Then there is assign function. This function is used to assign values to the vector. In this function there are two parameters. First one specifies number of values to be assigned and second represents the value that is to be assigned. Last is clear function. This function is used to remove all the elements from the vector. Now moving on to iterator functions. These are those functions that helps in iterating across the elements. First is begin function. It basically returns the iterator pointing to the beginning of the vector. The next is end function. This function returns the iterator pointing to the end of the vector. Now coming to capacity functions. These functions that lie under capacity are associated with size. So first is size function. This function returns the number of elements in the vector. Next is max size function. This function returns the maximum size that a vector can hold. Then there is resize function. This function changes the size of the container and inside the brackets a number n is mentioned. If n is less than the size of container, then content is reduced by removing extra elements. But if n is greater than the size of the container, then extra elements are added at the end so that it reaches the size of n. After that, capacity function. This function returns the size that is currently allocated to the vector container. At last, there is empty function, which checks whether the vector is empty or not. If it returns true, then it is empty, and if false, then it is not empty. Now, to understand these vector functions in a better way, let's do some examples of these vector functions in our code editor, that is VS Code. So first of all, let's make a new file and name this file vector.cpp. Now first of all we will write the header file, that is hash include iostream. Now we will write the header file hash include vector. This is the header file for vector because we are doing some examples on vectors, so that is why we have to use it. Now we'll write the namespace standard using namespace std. Now we'll start with int main. Now first of all we'll define the vector, so we'll write vector and inside the angle bracket we will write int, which is the data type. Now the name of the vector, we'll write n. Now first of all we'll see the functionality of assign function. As we know that assign basically puts the value at positions, so we will write n dot assign. Now first of all we'll write the number of values, like 9 is the number of values. After that, in the second parameter we'll write the value. Here it means that we are putting 1 to 9 positions in the vector. That is, we are assigning 1 to 9 positions. Now in order to print this, first of all we'll display a message saying the contents are. Now in order to print these contents, basically we have to write a for loop. We'll write int a equals 0. We'll initialize it from 0. Then a less than n dot size. This is the size function. It basically returns the number of elements. Now a++ will increment. We have to now print this. We have to write like an array in order to print all the elements. We'll write n and inside the bracket a. Now we'll leave some space. We'll write and l. We wrote and l over here in order to insert a new line. Now after that we'll see the functionality of another function, that is pushback. And we know that pushback functions adds an element at the end of the vector. So we will write n dot pushback and then the element which we want to add, like let's say 2. Now we have to display this last element also. So in order to display this, we will store the size of vector in some variable and then we will print the last element. So we will write int no, this is the variable name. Then we will write n dot size. Here we are storing the size of the vector in some variable no. Now we'll display last element. We'll display the message saying last element. And then we will print the last element, and as we know, in order to print the last element we have to print the n-1th element. So we will write n bracket no minus 1. Here we are writing n bracket no minus 1. This will print the last element. After that we'll write and l. Now after that we will see another function, that is popback. It basically removes the last element. So we'll write n pop underscore back. So this function will remove the last element that we have added, that is 2. So we need to print this also. So we'll write, first of all we'll display a message. Now the contents are Now we again write the for loop as we have done previously. We'll write int a equals 0, a less than n dot size, a++. Now we'll again print in the form of array. And inside the bracket we will write a. Then in order to give some space we'll write this. After this we'll write and l to add one new line. So firstly we displayed the contents Then we added one element at the end and then displayed that element. After that, we have removed that element with the help of popback function. As you have noticed that we are just doing the functions of modifiers yet. So in this example, we will cover some functions of modifiers only. Then in the next examples, we will do for iterator functions and then for the capacity function. So now let's do the functionality of insert function. As we know that insert function is used to add an element at a specified position. So we will write n dot insert n dot begin. It will point to the first element, then 7. As we know that the first parameter specifies position and the second specifies the value. So n.begin will point to the first position and 7 is the value. So now we will print it also. We'll write first element is, then we will write display the first element, then we'll write endl. Now we will use the function clear to remove all the elements. We'll write n.clear clear, and then in order to check, we will write n.size. So first of all we'll write now the size is, and in order to check whether all the elements are removed or not, we'll write n.size. It will display the size. The program is pretty long, but let's just hope it runs. Here it is. Now the contents are last element. Let's have a look whether it is right or not. 1 is displaying 9 times, then last element we have added 2, then we have removed that element. It is also correct. Then the first element we have added using insert, 7 is there, and after using clear function, now the size is 0. So this is the correct output. Now after doing this function, let's try another example. Now here we will do the example of iterator functions, in which first of all we will add some elements inside the vector and then we will print them using iterators. So let's start. First of all, name this vectors2.cpp. Now first of all we'll write the header file #include iostream. Then the header file for vectors #include vector. Then we'll use namespace standard. Now we'll start with int main. So here we will write vector, and inside the angle brackets we'll write the data type, that is int, and then the name of the vector, that is num. Now we will write the for loop, and with the help of for loop we'll add the elements inside the vector one by one. So we will write for int I equals 0, I less than, let's say 5, I plus plus. Let's make it 1 over here. Okay, now after that we'll push these elements one by one inside the vector. So we will write the function pushback. We'll write num dot pushback, and here I will write I. Okay, now because we want to add the elements from 1 to 5, so that is why we have to use less than equal to, because we want to include 5 also. Okay, now we have to print these elements, right? So we'll write, first of all we'll display that output from the beginning to the end. Okay, now we will write for loop, and with the help of iterators we will print the elements of vector. So we'll write auto, this is the iterator and A is the iterator name. Then we'll write num.begin. As we know that begin function points to the first element of the vector, so that is why we have written num.begin. Now we will write A less than, sorry, not equal to num.end, then A plus plus. Now after that we have written A not equal to num.end, and we know that end function returns the iterator to the end of the vector. And after that we have used increment operator, so this loop will run from beginning till it reaches to the end. And inside for loop we will write the dereference operator with A, so that each element which is getting pointed by A will display one by one with the help of loop. So let's write, we'll write cout dereference operator A, and then we'll give some space. Now let's try to run this. This is the output from the beginning to end, 1 2 3 4 5. This is our right output. This is the message which we want to display, and this is the output 1 2 3 4 5 which we want to display, which we have added in the vector and then we have displayed. So now let's do another example which includes the capacity function. So we'll make another file, vector3.cpp. So in this example we will add some elements in the vector and then we will apply some functions on it. So let's start. First of all we'll include the header file, #include iostream. Then the header file for vectors, #include vector. Then we'll write the namespace standard using namespace std. Okay, now we will write int main. So first of all we'll write vector and then the data type and then the name of the vector, let's say v. Now one by one we'll put some elements inside the vector. So we'll write for loop. We'll start with int x equals 0, x less than equal to 10, x plus plus. Because we want to add these elements, so we will write v dot push back and then we will write x inside the brackets, semicolon. Now here one by one all the elements from 0 to 10 will be added. Let's make it 1 to 10. Okay, now we will apply some functions on this vector. So let's first of all try out the size function. So first of all we'll write vector size is, and then we will write the function v dot size, and then we'll write and L. So this function will tell us the size of the vector because we have already added the elements from 1 to 10, so it will display 10. After that we will use the try out the capacity function. We'll write capacity of vector is, and then we will write v dot capacity. After that here also we'll write and L. Now we will use the maximum size or the max size. So we'll write maximum size of vector is. So in order to calculate the maximum size, we write v dot max underscore size and L. As we know that v dot size will give us the size of the vector, and capacity function, this function returns the size that is currently allocated to the vector container, and max size, this function returns the maximum size of the vector. So all of these functions result will be displayed because we have wrote them inside cout. Now let's try another function, that is resize. Now in order to resize the vector, we'll write v dot resize, and then we'll write the number that we want to resize it with, like let's write 5. Now in order to check this also, we will display. So we'll write vector size after resizing. Resizing is, I forgot to put the commas. Okay, now we'll write v dot size because now we want to find the size after resizing. So we have written v dot size. Now after that we will write and L. Okay, now we'll try the empty function. We'll put empty function inside if. Now inside if we'll write v dot empty equals false. It means if the vector is not empty, because we have written v dot empty equal to false, not true. We have written v dot empty equal to false. That means if it is not empty, then we'll display vector is not empty, and in else condition we will write vector is empty. So here we will write cout vec. Again I forgot to put over here. Okay, vector is not empty. And in the else condition we'll write vector is empty. So in this question, first of all, we have added some elements inside a vector. Then we have used v.size function, then v.capacity function, then max size function. After that, we have resized the vector and then check it for the size of it. After that, we use v.empty function. So now let's try to run this code. Okay, I think we have done something wrong. We haven't put the brackets over here. Okay, now let's try again. Here it is. Vector size is 10 because we have put 1 to 10. Then capacity of vector is 16. Okay, then max size of vector is this. Then vector size after resizing, because we have wrote the number 5 as we can see, so that is why vector size after resizing is 5. And vector is not empty, as we know, because inside the vector there are 5 elements, so it is not empty, which is true. So these were some examples of vectors in C++.
Moving on.
STL stands for Standard Template Library. It is a set of template classes that provide us data structures and algorithms or containers. It allows the programmer to use predefined functions, which helps them to write the code quickly and in an efficient way. For example, you are solving a problem that needs sorting. Now, instead of writing the code to sort, you can make use of STL. Now, STL mainly consists of 4 components, that is containers, iterators, algorithms, and function objects. So first is containers. These are collection of objects that store data of similar type. In STL, we have different types of containers. Some of them are array, vector, set, map, and these containers are generic in nature. So further, these containers are of 3 types, that is sequence container, associative container, and container adapters. Sequence containers, these are those containers that can be accessed sequentially. For example, vector, deque, list are some of the containers that store data in a linear form. Next is associative container. These are those containers that implement sorted data structures. In this, elements are retrieved via keys, and each associative container maintain its keys in sorted order. Example, set, multiset, map, and multimap. After that, container adapters. These containers are like sequential containers, but they are implemented by modifying their interface to provide the desired behavior. For example, stack queue and priority queue are some examples of container adapters. Now coming to iterators. In STL, iterator plays an important role as it links algorithms and containers. Iterators are those entities that helps in traversing through containers. They are used to point at the memory address of the STL containers. Iterators also helps in traversal from one element to the next element in the range using operators like increment operator. Iterator contains 2 functions, that is begin function and end function. The begin function returns the iterator to the first element, and the end function returns the iterator to the last element. Now coming to algorithms. Algorithms in STL can be defined as procedures that are applied to the containers and provide some operations on the content of the container. And because STL algorithms are built in, so that is why they save considerable amount of time. In algorithms, we just have to make a function call and we don't have to write the lines of code to implement it. Now let's have a look at types of algorithms. First is modifying algorithm, non-modifying algorithm, sorting algorithm, searching algorithm, and numeric algorithm. Modifying algorithms are those algorithms that make changes to the sequences. Swap and reverse functions are some examples of it. Then non-modifying algorithm. Non-modifying algorithm are basically read-only functions. They do not modify the data on which they work on. Some examples are count, equal, and search functions. Then sorting algorithms. This algorithm is used to sort the container elements. Its example is sort function. Next is searching algorithm. As the name suggests, this algorithm searches for the element. binary search algorithm is mostly used search algorithm. Last is numeric algorithm. This algorithm work on numeric values, or we can say it solves some numeric problems. Examples are accumulate function and partial sum functions. Now coming to function objects. Function objects are also known as functors. A function object is an object of template class that implements call operator. This call operator allows the object to be used with same syntax as regular function call. For example, suppose you have declared an object obj of a class in which operator is defined. Then you can use the object obj just like a normal function. Function objects also helps in generating the data, and it also helps in testing purposes. Now, in order to do some examples, let's move to our code editor, that is VS Code. So here we will do an example of vector container. So let's make a new file. And let's name it stl.cpp. Now we'll add the header files. Now writing namespace standard. Now we will add, before namespace standard we have to add the header file for vectors, because we are doing the example of vector, so that is why we have to add the header file of vector. Okay, now we'll write int main. Now first of all we'll declare the vector. So we'll write vector int within the angle brackets. Now we will write the name of the vector, that is v. Okay, now we have to push some elements inside the vector. For that we have to use for loop. So we'll write for keyword int I equals, let's say 1, I less than equals 10, I plus plus, that is increment operator. Okay, now we have to push the elements one by one, so we'll write v dot push back, and inside the bracket we'll put I. So the elements will keep on adding one by one at the end of the vector. So now we will check the size of the vector. So we'll write the message size and then the function v dot size. It will tell us the size of the vector, that is the number of elements inside it. As we can see that we have put 10 elements inside the vector one by one, so it must be 10. So in order to check it, we have used this function v dot size. Okay, now we'll use another function, that is v dot resize. It will resize the size of the vector. So whatever we put inside this bracket, like let's say I've put 7, so its size now would be 7. And we need to check this also. So we'll again use the function size. So first of all we'll display the message. After resizing, it becomes v dot size. It will print the size of the vector after resizing. Okay, now we use another function v dot empty. For that we have to use if condition. So we'll write v dot empty brackets we know that if v.empty equals true, then it means it is empty, and if it equals false, then it means it is not empty. So we'll simply display the message that it is not empty. We'll write cout, and now we'll write with /n not empty. We forgot to write the commas over here. Okay. Now in else we will write it is empty. It is empty. We can also do this the other way around, like we can put v.empty equals to true, and then inside that bracket we can write it is empty, but it's your choice. Okay, now we'll display the elements of the vector. For that we have to first write the message. So we'll write elements of vector. Then after this, using for loop and iterator, we will print those elements. So let's do this. We'll write for, and inside for loop we'll write auto it. Here the auto keyword specifies the type of variable that is being declared will be automatically deducted from the initializer, and it is the iterator. Now we'll write it equals v.begin, and we know that v.begin function will point to the first element of the vector. So after that we'll write it not equal to v.end, and it will point to the last element of the vector. Now we'll write it plus plus. Now we'll print the iterator using dereference operator, and in order to make some space we'll write this. Now we return 0. Okay, now let's try to run this. Okay, here is the problem, I think. Now let's try one another time. Here it is, size 10. After that, after resizing, it becomes 7. Firstly, we add the elements by pushing one by one using the pushback function. 10 elements were added, so size is 10. After that we have resized it, so after resizing it becomes 7. And then we have used the function empty, so it was not empty, so that is why the message displays not empty. Then the elements of vector, I forgot to put space over here, and elements of vector 1 2 3 4 5 6 7, and that is correct. Okay, now we'll do one example of iterator. In this example we'll simply print the elements of a vector using iterator. So first of all, let's name this stl2.cpp. Now we'll write the header files, #include iostream. In this we'll add 3 header files. Now we'll write #include iterator, because we have to use iterator, so that is why we are doing this. And we also have to use the vectors, so we'll write hash include vector. Now we'll write namespace standard. Now we'll start with int main. So first of all, we'll declare a vector in which there are some elements. As in previous question, we already learned how to add elements in a vector. So in this question, we'll simply declare those elements inside a vector. So we'll write vector int inside the angle brackets. Now let's say AR is the name of this vector. Now we'll write the elements. Five elements are there. Now we have to declare iterator to a vector. So this is how we'll do it. We'll write vector, then the data type inside the angle brackets. Then after this, we'll write the scope resolution operator like this. Now iterator keyword, then the name of the iterator, that is PTR. Now we'll display the vector elements using for loop and using the functions begin and end. So we'll write, first of all, we have to display a message. Okay, we'll write the elements of vector R. Okay, now semicolon. Now using for loop, we'll write the PTR, that is the iterator, AR dot begin. As we know that AR is the name of the vector. AR dot begin. Begin function will point to the first element of the vector. Then PTR less than AR dot end. We know end function will point to the last element of the vector. Okay, now we'll write AR plus plus. Sorry, PTR plus plus. Now we have to display it, and we'll display it using dereference operator and the name of iterator, that is PTR. We'll make some space. Now at last we'll write return 0. Now let's try to run this. The elements of vector are, as you can see, the elements of vector are 1, 2, 3, 4, 5. So this is how you can print the elements of a vector using the iterator. Here is the vector, and with the help of iterator, we have printed these elements 1, 2, 3, 4, 5. Now we'll do one simple example of algorithm. First of all, let's name this stl3.cpp. Now in this example, we'll use swap algorithm to swap two integers, and we know that swap is a template function. So let's do this. First of all, we'll write hash include iostream. Now using namespace standard, we'll start with int main. Now first of all, we declare a variable, let's say 7, and second variable, let's say 10. First of all, we'll display the value of these variables, that before swapping and after swapping. So that is where we'll write value of I. Now here we'll write value of j. And L. Okay, now we'll use the swap algorithm, and here we'll mention the elements we want to swap, I, j. It will simply swap the contents of these two elements. Now we'll write after swapping. And L. We'll do same for j. This is a very basic example, but we have to see the functionality of it. We'll write and L. Okay, now we'll write return 0. Now we'll run this. Yeah, value of I 7, value of j is 10. After swapping I 10 j 7, it will look better if we have wrote like this. Let's make it look good. Yeah, value of I is 7, value of j is 10. After swapping, I becomes 10 and j becomes 7. So this is how we can swap the elements using swap algorithm. There are some more algorithms, you can try those as well. And now at last we'll do one example of function object. Let's name this as stl4.cpp. Alright, now we'll add the header file. Hash include iostream. Now we'll write namespace standard. Now in this question, first of all, we'll start with the function. So first of all, we'll make a class function obj. Now we'll write access specifier public int. Here we'll write the call operator. As we know the syntax, operator, bracket, then another bracket for the arguments, int x, comma, int y. So this is the syntax of it, and now whatever we want to do with these two variables, let's say we want to multiply. So we'll write return x into y. Alright, as this is a class, so we have to write the semicolon. Now we'll write int main. Okay, now we'll write int main. After int main, here we will write the name of the class, because we have to define the object of it. Now the object is fo. So here class name is function obj and its object is fo, and as I have explained earlier, here I can use fo object like a normal function, because fo is the object of class function obj in which call operator is defined. So it will act like a normal function. So now we'll make a variable, let's say multiply. So we'll write mult equals f4, and because it acts like a normal function, so we'll pass the parameters 4 and 7. Now in order to display, we'll write cout and we'll write multiplication of x and y is, now we'll write the name of the variable mult, because the result is getting stored in mult variable. Now we'll write return 0. Now let's try to run this. Here we can see multiplication of x and y is 28, and that is true. 4 into 7 equals 28. So it is working, and this is the example of functor or function object. Let's go ahead and have a look at why enums are used in C++. Enums are short for enumerations. These are basically used when we have some set of possible values and we have to select one out of it. For example, suppose you are the shop owner and you have 4 types of coffee in your coffee machine. That is cold coffee, hot coffee, black coffee and mocha. And you don't want the trouble of customer putting any other coffee name in the machine which is not there. Then in situations like these, enumerations are used. Because in enumerations we have to choose from predefined values, and it is also helpful for documentation and readability purpose. Now let's understand what is enumeration. Enum or enumeration is a user-defined data type in which a set of values are specified for the variable, and the variable can take out any value from the set of values. And it is also a way to use integers to represent values. We can assign values to enum, but if we do not assign any value, then the compiler assigns value to them starting from 0. Coming to its syntax, which is enum, that is the keyword for enumerated type, then enumerated type name is written, then under brackets possible values of type enum are written. For example, here enumeration name is player and values are Ronaldo, Salah, Messi, Neymar, which are the names of players. In this example, by default, Ronaldo is 0, Salah is 1, Messi is 2, and Neymar is 3. Because we know by default compiler assigns them value which start from 0 and so on. But we can change these default values by assigning values to them. Like here, Ronaldo's value is now 4, Salah's value is 2, Messi's value is 8, Neymar's value is 1. Now let's have a look at an example in which we will print the default value of months. So in this example we have enum name as months and enumerated values as January, February, March and so on. And in order to access these values we have written enumeration name and after that the variable. As we can see inside main function, m is the variable and its type is months. Now here we have assigned the month March to the variable m, and then we are printing the variable m plus 1. Here plus 1 will print the value next to the month March, that is 3, and similarly if we write plus 2 then it will print the one next to it, that is 4. These values are default integer values. After printing the output, value is 3 because we have printed m plus 1 where m is 2 and plus 1 makes it 3. Now let's understand how to use enum with flags. In this example we will choose a mobile having any of the 2 features among 3. Here the name of enumeration is mobile and its enumerated values are battery capacity, camera quality, large storage, and we have assigned values to them 1, 2 and 4 respectively. And because we are doing this example of enums with flags, that is why we are using integer values of power 2, because it avoids the overlapping. Inside the main function we are using bitwise OR operator because we want to choose the mobile having both camera quality and large storage capacity. And we know that bitwise operator adds the binary of 2 integers. So the value of camera quality is 2 and value of large storage is 4. When we use a bitwise OR operator in between these two features, so it will add up their binary, giving the decimal number as 6. So the output 6 is showing both the camera quality and large storage are used. Now let's do some examples of enumeration in our code editor, that is VS Code. Okay, now let's make a new file and name the file as enum.cpp. In this example, the enumeration name will be captain and the enumerated values will be the team members, out of which we will select one member as captain. And with if condition, we will verify if he is the selected captain or not. It will be a basic example. So first of all, let's write hash include iostream. Now we'll add the namespace standard. Okay, now we'll write enumeration enum captain, which is the name of the enumeration type, and now we will write the enumerated values, which is let's say Avi, Sid, Robbie, Sammy and Jake. These are the team members. Now we'll write int main. Now here we will first of all write captain, which is the name of the enumerated type. Then we'll make the variable out of it, cap, and let's say Avi is the captain, so we'll write Avi. Now here we will write if condition. We'll write if cap equal to Avi, then we'll display our captain is Avi and its value is whatever the value. Avi's value here is 0, so we'll display that. So we'll write our captain is Avi and its value is, then we'll write Avi. As we know that Avi is at first position, then its value would be, default value would be 0. Okay, so here we will write endl. Now in else, here if we put Sid, Robbie, Sammy, Jake as captain, or if we declare them as captain, then this message would be declared, which we will be writing in else. So the message would be he is not our captain. Then over here we will write return 0. Okay, now let's try to run this. Our captain is Avi and its value is 0. Because here captain we have declared Avi, so that is why this is printing. If we write, let's say, Sammy over here, then it will print the else part. He is not our captain. And if we write Jake or Sid, then also it will print the same. He is not our captain. Only in case of Avi, it will print our captain is Avi and its value is Avi's value. So this was the basic example of enumeration. Now let's move on to another example. Now let's make a new file and name it as enum2.cpp. Okay, now we will add the header files #include iostream and using namespace standard. So here we will do an example in which enumeration name will be supercars, and to the values we will assign some integers to them, which will be the speed of those cars, and then we will compare them using comparison operator in terms of speed. So we will write enum, then name of enumeration, that is, let's say, supercars. Okay, now inside the bracket we'll write the name of the cars, which are the values, and we will assign some integers. These integers are actually speed of these cars. $268, then Valkyrie, speed is 240. Now Roadster 250. Okay, now as you have created the enum, now we will start with int main. So we will write the enumerated type name supercars. Now the variable speed 1, because we want to create two variables in order to compare them. So first we will create speed 1. Now again speed 2. Now we will assign the two cars that we want to compare to these variables. So speed 1 will be Valkyrie, and speed 2 would be Roadster. Okay, now we will write the if condition, and inside the if condition we will compare the speed of these two cars. So we will write speed 1. If speed 1 is less than speed 2, okay, then we will print that it's a win for Roadster, because speed 2 is Roadster and speed 1 is Valkyrie. So we'll write it's a win for Roadster. With the speed, we'll also write the speed with the speed of this speed 2 will display the speed of Roadster, that is 250. Okay, now else condition. So here we will write it's a win for Valkyrie. With the speed of, here we will write speed 1. Okay, now we have to write int main, but before that we will write the bracket which we forgot to mention, return 0. Okay, I think it's done. Now let's try to run this. Here we can see it's a win for Roadster with the speed of 250. as we know that the speed of Roadster here is 250 and the Valkyrie speed is 240. So when we compare it, speed 2, that is Roadster, wins because Roadster is 250. So this was the second example. Now let's do one last example. Let's name this. Okay. enum3.cpp. We'll write hash include iostream. Now namespace standard. Now in this example we will see how to use switch statement with the enumeration. Okay, so first of all, inside int main we will write enum. Color is the name of the enumeration type. Then we'll write the values: red, blue, green and yellow. These are the values. Now here we will use switch statement, but before doing that we have to assign one color to a variable. So first of all we have to create that variable, and in order to create the variable we will write the enumeration type name color and then the variable name select. Now we will assign one color from the above colors. Let's say yellow. Now in switch statement we will write, first of all we will write switch statement, switch, and we will pass here the variable, that is select. Basically we are passing yellow because yellow is assigned to the variable select, and that is why it is getting passed. So now case 1, that is case red. First of all we'll write the case red with a colon in the end. Now we will print that it is red. Now we'll write the break statement. Break statement basically ends the case or terminates the case. So after that, the second case, that is case blue, colon. Now here we will print it is blue, and similarly break statement. We'll do same for all of these colors, green and yellow also. And switch statement will help us to find which color is passed and will display the message of that color. So here we will write green, it is green, break statement. Now case yellow, now we'll write it is yellow. Now here we'll write break. Okay, now at last we have to write return 0. Now as we know that we have passed a particular color to the variable select, and select is the expression, and switch statement will help us in comparing the variable select value to the value of different blocks and one which matches that particular block will execute. Okay, now let's try to run this one. Here we can see it is yellow is being printed, which is the right answer because we have passed the color yellow to the select. That is why only the case yellow output is being printed. So this is how you can use switch statement with the enumeration. In this session we are going to learn about C++ GUI, that is graphical user interface, and how to configure Visual Studio and make a GUI application. To develop C++ GUI or C++ graphical user interface apps, we must have an IDE that supports C++ GUI applications, and Visual Studio is one of the best IDE for that. Here IDE stands for Integrated Development Environment. There are many versions of Visual Studio for GUI apps, but I suggest you to download Visual Studio 2019. There are 3 editions of Visual Studio 2019, that is Community, Professional and Enterprise. We can download the Community edition. Once the Visual Studio is downloaded and installed, then you need to launch this application. After that, you can select the color theme and change the development settings to Visual C++. Then the Visual Studio will look like this. Then here we will click on this Create a New Project. And now we have to search for a project template named CLR empty project.NET framework. So we'll type CLR empty project.NET framework. Here it is. Make sure that there is .NET framework over here. Now all we have to do is to click on this and select next. Now here we can name our project. Let's say I have named it project 2, and we can select the location, and now we can click on this create button. Now our project is being created. So here it is. So now let's create a form file by going to the project, then add item, add new item. Now here Visual C++. Under Visual C++, we'll click on UI and then Windows Form. We'll click on this Windows Form and click on this Add button. So our file is loading. So it will show you this error, but you don't need to worry about this one. You can simply close it. Now we will go to Project, then into Properties. Then now we'll click on this linker, open this linker. Now we'll go to this system. Then inside this subsystem over here, we'll select Windows. Here it is. Now after doing this, then we go to Advanced, and in Advanced we can change this entry point to main. We'll write main main. This main is the starting function. Now we can press OK over here. Now you need to open this myform.cpp. Here it is. And you have to copy this code and just paste it over here. We will add this code in the description. You can take this code from there and add it. Now make sure to write your project name over here. Like my project name is project 2, so I'll write project 2. Yes. So after doing this, we can save it by pressing Ctrl and S, and now we can go to myform.h. Here we can see there is no form, so we need to save it and close this Visual Studio once. Now we need to open the Visual Studio again. We'll go over here, we'll write Visual Studio 2019, here it is. We'll click on this and this is launching. We can click on this project too. Now let's go to myform.h. We'll click on this. It is getting loaded. Here we can see the form. Earlier we were only able to see the code, but now we can see this form. Now we can check this by running it by clicking on this local Windows debugger button. We'll click on that and let's see if it is running or not. It will take some time. So here it is running properly. As you can see, this is my form and this is ready to use. So the debugging is going on. So if we have to close the debugging or stop the debugging, we can click on this cross button. So the debugging is closed now and we have verified that the form is running correctly. We can also add some buttons and labels to this form like this. We can click on this toolbox, then we can select this button and we can click this over here. So this is our button and we can select some more labels. Alright, we can click on this toolbox again and select another button like this over here, and now we can select a label, let's say, and click over here. And we can also adjust the size of these buttons like this, and like this we can adjust the size. And this is the label. We have to adjust its size by setting its format. We can do it by clicking on this label and going to properties. Over here we can see, as you have clicked on the label, so we can see the text, that is label 1. Here we can see text label 1. So it is this text which is written. We can change this one by clicking on this. We can select hello there. We can write like this and it will be shown over this side. Now we must click the label first, then only we can access the button or label. So now let's say this is the font, so we can click on this font and adjust this. Here it is. Let's say I have adjusted it to 18 size and made it bold. Now we can click this OK over this side. So here we can see hello there, it is bold now. Similarly we can do this for button as well. As we have clicked on this button, as you can see, now I can go to this properties. Now inside this properties there is text, that is button 1. We can see, we can change this, like we can write click here, and we can also adjust its font. Here it is, let's say 12 and bold oblique. We click on this OK and here it is. Click here, we can adjust it over there. And suppose if we want to delete some button or label or something like that, so we can click on this and right click on this side, and here we can see delete. We'll click on this delete and it will be deleted. There are more options in toolbox, like there is text box, list box, list view, picture box, checkbox, etc. We can select as per our choice, and we can adjust its layout or editing by going to the properties column. So now let's make a calculator program. So for that we have to create a calculator layout. So let's just delete all these. Delete this one, and we'll delete this one as well. Now we'll go to the toolbox and select a text box. We can search it over here. Text box. Here it is. We can click on that and put it over here. Here it is. We have to adjust its formatting. So we'll go to properties and we'll go to font. We click on this font. Now let's say adjust it to 22 and make it bold oblique. Yes. Now we'll click on this OK, and we have to create another one. So instead of doing this all, we can copy this one, and to copy this we can go to this side and right click over here, and we can click on this copy, and then we can paste it. Here it is, because we have to enter two numbers, and for that we need to have two text boxes for a calculator. Alright, now in between we can mention the operation or operator whatsoever. For that we have to select the label, and we'll go to toolbox, and here it is, text box, but we have to select label. Alright, label. We'll click on this label and put it over here. Now we have to adjust it. Now here we will write, let's say its font would be 20 and it would be bold oblique. It will look nice. Then click on OK. Now we have to adjust what is written inside it. So we can go to text and click on this label 1. Now we can write operator, but it would be so long, so we can write OP, that means operator. Alright, it gives the idea about the operator. We have to adjust it a bit. Alright, here it is. And okay, now we have to create a buttons for addition, subtraction, multiplication. So we'll go to toolbox, and now we'll search for buttons. We'll click on button and put it over here, and now we'll adjust it by going to properties and going to fonts. Let's adjust it to 22 and make it bold. Now we'll click on OK. And now we have to change the label of it. First of all, let's select its layout like this. It would be big. Now we'll go to properties and we'll go to text, and we'll make an addition sign over here, and now we'll click on this. So here we can see. So now we'll copy this button to create the next 3 buttons. So click on this copy and paste it. We'll do this for the other 2 as well, and we'll change the text by going to properties later onwards. Here it is. So first will be addition, then here let's make it subtraction. We'll go into properties, we'll click on this properties. Now let's make this text as minus. Alright, now we can also change the color of this text. let's say we can make this color. Here it is, blue in color. Now we'll change this one. We'll go to properties and make this as sign of multiplication, but we'll press X so that it'll look nice. Alright, now this one, we'll go to properties and change this to division sign, and we can change this one as well. It will look nice. Let's make it this similar color to the subtraction. Alright, here it is. Here are 4 buttons: addition, subtraction, multiplication and division. Now we have to display the result as well, so we'll go to toolbox and we'll search for label. We'll click on this label and put it over here. Alright, let's make it like this and let's put it over this side. It will look nice over here. Properties, now we have to adjust it. Let's make it 22, bold oblique. Okay, here is our result and let's name it as result as well. We'll go to text. Here it is, label 2 written. We'll write result. Now whatsoever operation is done, its result or output is displayed over this side. Now all we need to do is to add the functionality to these buttons. So let's do that. We'll click on this 2 times on this button, and the button name, actual name of that button is button 1. So here it is. So this part is for button 1 and we know that button 1 is addition. So we need to do addition over here. So let's start. First of all, we'll have to declare a variable int result or output or answer, whatsoever we want. Let's write output. Now to add those, we need the names of those 2 text boxes. So we'll go to format design and we need these names, both of these text box names. So we'll click on this first and we'll go to properties. So here it is, text box 1 we can see, and we click on this and properties. This is text box 2 and this is similarly, this is button 1, button 2, button 3, button 4. We can check this by going to properties and by clicking them and going to properties. So this is text box 1 and this is text box 2. So now we know the names. Now all we have to do is to write text box where B is capital. We have to write the exact name. We can check it over here that this is text box. We can check the spelling. This is text box 2, this is label 1, this is button 1, this is button 2. We can check the spellings from there. Now we have to use the arrow operator. We'll write like this. This is the arrow operator. This will give us the access to the members of the object. Alright, so we have to change the text. So we'll write text with T capital. Alright, now we have to add the text box 2. And we'll do it same. We'll write this arrow operator and text. Now this addition which we have written over here is wrong, because we are actually adding the strings. As you can see, when we type any number over here, it is a string, and same goes for this part. So we have to convert it. First we will convert both of these text to integer, and then we will again convert the result into string, because we have to display it over here, and for that we need a string. So then again we have to convert it to the string, and let's do it. So what we gonna do is we'll write system, then this scope resolution operator, convert, again scope resolution inverter operator, to int 16. I must be capital, keep in mind, to int 16. Alright, now here we'll write text box with B capital, and then this arrow operator, and we'll write text. Alright, after that sign of addition, again we'll do the same, system scope resolution operator, convert scope resolution operator to int 16, and text box 2, here we have to write text box 2, arrow operator, text. Alright, here is the addition part. Now we have to display the result. Now to do that, first check the name of the result. Like this is the result. We'll click on this and go to properties. Its name is label 2. So we have to make the changes into label 2. We'll go to this form H. Now we'll have to change the text, that is we have to change the result that is written into the output. So for that we will write label 2, which is the name, then this arrow operator. After that we'll write text because we have to change it, and then we'll write system scope resolution operator, convert scope resolution operator to string, because we have to display the output into string, as I have already told you. Alright, now over here we have to write output, this output. Okay, so let's check if it is working or not. We'll go to local Windows debugger and click on this. Hope it works. Here it is, my form. So let's try to add, let's say 5 plus 9, and we'll click on this add button, 14, and we know that 5 plus 9 equal to 14, so it is working fine, we can see. And now we have to do this for all the buttons, that is subtraction, multiplication and division. So let's go ahead and do that. Let's first close this debugging. We have stopped the debugging and we'll go to this. Now we have to do that for the next 3 buttons. So alright, now we'll click on this subtraction button 2 times. Here we can see now the code is same for all of these, and so we can copy the code from here, and we have just copied it and we'll paste it, and we'll make the changes in the sign. Like I have used here minus sign for the subtraction, and the rest is good. Yeah. Alright, now we'll do it for the next one, that is multiplication. I'll double click on that, and here it is. We'll copy the code from here and paste it. We'll change the sign, the subtraction, not the multiplication sign. This is the multiplication sign. And now the next one, that is division. Here we go. We'll again select, copy and paste. Let's change the sign of this as well. Okay, as we have done the changes, so let's save it by pressing Ctrl and S, and it is saved. Now let's try to run this. Hope it works. We'll click on this local Windows debugger. It usually takes some time, and here it is. So let's try now. 5 plus 6, let's do this first of all, addition. 11. Now we'll do 20 minus 6, so we'll click on this minus, and 20 minus 6 equals to 14. That's right. And now we'll do 20 into 3, that is 60. We'll click on this multiply sign. 20 into 3, that is 60. It is right. Now let's say 15 and 3. Yeah, we'll click on divide, and this is 5. So all of our buttons is working fine. So this is how we can create a calculator in Visual Studio 2019. You can also create this calculator program in your PC. All you need to do is to download Visual Studio 2019 and install it, and you can follow the steps and you can create this calculator application. In this video, I present you some commonly asked C++ interview questions. These questions will help you in your preparation and serve you as a valuable resource while preparing for the interviews. In this video, we will cover some conceptual questions, multiple choice questions, output-based questions, and some programming questions of C++. So without further ado, let's get started. Starting with the first question, that is, what is the difference between C and C++? Now, C language is a procedure-oriented language, whereas C++ is partially object-oriented language because it doesn't support object-oriented features completely. C language supports top-down approach and C++ supports a bottom-up approach. Here the bottom-up approach means the development of modules in C++ starts from the bottom. C doesn't support function or operator overloading, whereas C++ supports both function and operator overloading. C language doesn't support virtual and friend function. C++ language supports both virtual and friend function. C language has 32 keywords, whereas C++ has 52 keywords. Next question is, what are classes and objects in C++? A class is a user-defined data type that contains data members and member functions. It is defined with keyword class. Objects are defined as an instance of a class. Once the object is created, then it can operate on both data members and member functions. Coming to the third question, that is, what are access modifiers? Access modifiers are used to define accessibility for the class members. It defines how the members of the class are accessed outside the class scope. There are three types of access modifiers, that is private, public, and protected. Let's start with private. The members who are declared as private cannot be accessed directly from outside the class. They can only be accessed by the member functions inside the class. Now public. The members who are declared as public can be accessed from within the class as well as outside the class, and even from outside the package as well. Now protected. The members who are declared as protected can be accessed from within the class and from the derived class. Now coming to the next question, that is, what is C++ OOPS concept? OOPS stands for Object Oriented Programming. There are some concepts of OOPS, that is, object, class, inheritance, polymorphism, encapsulation, and abstraction. Now let's understand these concepts. Let's start with object. An object is a basic unit of object-oriented programming. It can be defined as an instance of a class. We can create multiple objects of a class. Now class is a template of an object. It is user-defined, which holds member functions and data members. The data and code which is defined inside the class are said to be the members of the class. Now inheritance. Inheritance can be defined as a process in which child class inherits all the properties and behavior of its parent class. The class which is inherited is called the base class, and the class which inherits is called the derived class. Now polymorphism. Polymorphism is the ability to give different meanings to the same function. It allows us to redefine a function and create it with a completely new definition. Now encapsulation. Encapsulation means binding code and data together into a single unit. Now abstraction. Data abstraction specifies hiding the internal details for the simplicity and showing the functionality to the user. Now coming to the next question, that is, what is the difference between a while loop and a do-while loop? So first is while loop. While loop verifies the condition. If it's true, then it iterates the loop till the condition becomes false. On the other side, do-while loop first iterates the loop body once, then it checks for the condition. In while loop, the syntax is while keyword, then condition inside the brackets. The syntax of do-while loop is do block, and after that while keyword with a condition. In the while loop, if the condition is false, then not a single statement will execute inside the loop. On the other hand, in do-while loop, if the condition is false, then also the body will execute once. Now, coming to the sixth question, that is, what is a constructor? A constructor can be defined as a member function that is invoked whenever we create an object. It has the same name as that of class. There are two types of constructors in C++, that is, default constructor and parameterized constructor. Default constructor are those constructors which do not take any parameters. If we don't define any constructor, then the compiler will automatically provide a default constructor. On the other hand, parameterized constructor are those constructors in which we can pass the arguments. Now, coming to the next question, which of the following operator cannot be overloaded? Our options are A. Subtraction operator, B. Addition operator, C. Ternary operator, and D. Modulo operator. So our correct answer is C. Ternary operator, because overloading this operator is not syntactically possible. So let's move on to our next question. Write a program to find the factorial of a number. So here we have to write a program of factorial in which we will enter a number and its factorial is displayed on the screen. So here we have declared an integer n, which we will take an input from the user, and another variable fact which we have initialized as 1. After that, we have displayed a message, enter a positive integer, and we have taken an input of the integer. Now if the number or integer entered by user is less than 0, that is in the negative, then it will display error as there is no factorial of negative number. And all the positive number will go to the else block. Inside the else block we have used for loop, and it is iterating from 1 to n, that is the number users had entered. And inside the for loop it is written fact into equal to I, which can also be written as fact equal to fact into I, which means one by one all the numbers from 1 to n will be multiplied by fact variable, and the result will be stored in the fact variable itself. Once the iteration is done, then the fact variable where the result is stored is displayed. So this is the factorial program. Now coming to the 9th question, that is, what is operator overloading? Operator overloading is a mechanism in which we provide an additional meaning to the operators. In this, an operator is overloaded to give user-defined meaning. For example, we can overload an addition operator in a class like string to concatenate two strings by only using addition sign. Now, our next question is, what if we compile a program without the main function? Now, another question arises, is it possible to compile a program without the main function? So the answer is, yes, we can compile a program without the main function, but we cannot run or execute the program because the main function is the entry point from where all the execution begins. And without the entry point, the program is not executable. So we can compile the program, but we cannot run it without the main function. Now, moving to the next question. What is operator overloading and function overloading? As we have already discussed operator overloading allows operators to have an extended meaning apart from their predefined meaning. Function overloading, on the other hand, defines a method in such a way that there are multiple ways to call them. Now, our next question is, what is the difference between equal to operator and assignment operator? The equal to operator checks whether two values are equal or not. If equal, then it's true, otherwise it will return false. The assignment operator, on the other hand, assigns the value of right variable to the left variable. Coming to the 13th question, that is, when void return type is used. Void return type is used when we don't want to return any value. It specifies that the function doesn't return a value. Function with void return type completes its task and then returns the control to the caller. So our next question is, what is call by value and call by reference in C++? First of all, both of these methods, that is call by value and call by reference, are the methods to pass the values to the functions. So let's start with the first method, that is call by value method. In call by value method, we pass the copies of actual parameters to the function's formal parameters. This means if there is any change in the values inside the function, then that change will not affect the actual values. In call by reference method, the reference or address of actual parameters is sent to the function's formal parameters. This means any change in the values inside the function will be reflected in the actual values, because here we are sending the address of the values. Coming to the 15th question, that is, what is inline function? The inline function is expanded inline when it's called. When this function is called, the whole code of inline function gets inserted or substituted at the inline function call. Or in other words, the compiler replaces the function calling location with the definition of the inline function at compile time. Its syntax is the inline keyword, return type and function name, and parameters inside the brackets. Coming to the next question, that is, what are pointers in C++? pointers are the variables that holds the memory address of another variable. The type of variable must correspond with the type of pointer. For example, the pointer of character type can hold the address of character type variable, and the same goes for integer and other data types. Its syntax is type of variable and asterisk sign with the name of pointer. Moving to the next question, that is, what is scope resolution operator? A scope resolution operator is represented as shown. This operator is used to associate function definition to a particular class. This operator is used for the following purposes: to access a global variable when we have a local variable with same name. Second is to define a function outside the class. Now moving to the next question, and this question is output based question. So the question is, what is the output of the following C++ program? So in this question we have to determine the output of the following program, and we have to select the correct answer from the following options. So in this program, as we can see, two variables I and X are initialized as 0, and after that do block is there, and we know that do block executes for once regardless of any condition. And inside the do block there is if statement, in which the condition is if I mod equal to 0, then only the block will execute. So if I is initially 0 and we know 0 mod 5 is 0, so the condition is satisfied and it will display 0 as the value of X. X is 0 initially. After that the value is incremented for both I and X. Now the value of I is 1 and 1 mod 5 is 1, so it doesn't satisfy the condition. So the value of I will increment again, and similarly the process will repeat for 2 mod 5, 3 mod 5, 4 mod 5, but 5 mod 5 is 0. So the value of X here, which is 1, now will be displayed and increments to 2. Then afterwards I becomes 6, then 7, then 8, then 9 on incrementing, but doesn't meet the condition at that time. But when it becomes 10, the control will move outside the loop and 2 will be displayed. So our answer becomes 0, 1 and 2. So this is our answer, 0, 1, 2. Now let's move on to the next question. So this question is a multiple choice question, and in this question we have to determine the size of integer data type. So our options are 4 bytes, 1 byte, 8 bytes and 2 bytes. So our answer is 4 bytes. 4 bytes is the size of integer data type. So now let's move to the next question. This question is, what is std in C++? First option is std is standard class in C++. Std is standard file reading header in C++. Std is a standard header file. Then last option is std is standard namespace in C++. So our correct answer is std is a standard namespace in C++. It is used in programs while writing using namespace standards, and it tells the compiler to take everything in standard namespace. So let's move on to the next question. So in this question we have to tell how to input a string in C++ with spaces. Now we all know how to input a string in C++ without spaces because it's quite easy. But let's understand how to do it with spaces. So in this question, as we can see, there is a string that we have declared S. The name of the string is S. After that we have displayed a message, enter the sentence with spaces. And then we are taking the input. Here getLine is the member function of iStream class, which is used to read the string with spaces. So as we can see, getLine, after that in the bracket cin, which is used to take the input, after that the name of the string, that is S, and after that we have displayed the string name, that is S. So this is how we can take the input from the user with spaces using this getLine function. So let's move to our next question. That is, what is the difference between new and malloc? Now both of these are used to allocate memory. So let's start with new. New is an operator, whereas malloc is a function. The new operator calls the constructor. On the other hand, malloc function doesn't call the constructor. In case of new, there is no need to specify memory size while using new operator. In case of malloc, we have to specify the memory size in malloc function. New operator can be overloaded, whereas malloc function can never be overloaded. Now next question is, what is the difference between prefix and postfix? In prefix, first the value is incremented and then the value is assigned to the expression. But in case of postfix, the value is assigned to the expression and then the variable's value is incremented. Now coming to the next question, that is, what is the output of the below C++ program? So as we can see the program, this is the program of enumeration. As we can see the enum keyword. So here 3 enum variables are there, that is blue, green and great. And we know that there are some default values that are assigned to the enum variables that starts from 0. But we also know that we can change these default values. So as you can see in this question, green equals 5. So green's value is 5. And we can see the element great has no value. So in enum, if this case arises, then the value of the next element would be 1 greater than its previous element. So ultimately, the value of great element would be 6. So as you can see, here we have printed blue and great. So our output would be 0 and 6. That means the value of blue is 0 and the value of great is 6. So now let's move on to the next question. In this question, we have to find the frequency of a number in C++. So as you can see in the program, we have given this number 13324222523 and we have to find the frequency of the number 2. That is k equals to 2. K is the number. So in this program, first of all, we'll pass both of these values to a function named frequency. Now inside that function, we have declared a counter variable c and initialized it with 0. Now after that, we have used while loop, and inside the while loop we have put the condition num greater than 0. Now it means the loop will execute till the value of num is greater than 0. Now after that, inside the while loop we have put an if statement condition, that is num mod 10 equals k. Now keep in mind that k is the number which we want to find the frequency of, that is 2. Now num mod 10, we know that any number when mod with 10 gives the last digit of that number. So one by one, all the digits of this num variable will be checked, starting from 3, then 2, then 5, then 2, then again 2, then 4, similarly goes on. So one by one, all of these digits will be checked with the value of k, that is 2. And if the digit matches with k, then that counter variable which we have initialized as 0 will increment. And after that, num equals to num divided by 10 will delete that last element so that the repetition of digits don't occur. So this is how we can find the frequency of a number in C++. So now let's move on to the next question. Which of the following statement is correct about the program given below? This is again an output based question. So let's have a look at the program. And these are its options: 7, 14, 0 and 1. So we have to select one out of it. So in this program we can see a variable x is declared and a pointer p is there. And we have assigned this value 7 to the variable x. After that, we are storing the memory location of x to this pointer p. And at last, we are displaying the output using the dereference operator, as we know that if we want to display the value at an address, then we use dereference operator. So our output would be 7, as the value at that memory location is 7. Now let's move on to the next question. Which of the following statement is correct about the program given below? Now in this question, again we have to determine the output. So let's have a look at the program. As we can see, there are 3 variables x, y and z, and we have initialized them 2, 4 and 5 respectively. And after that, we are calling a function duplicate and we are passing the values. But in this case, we are passing the values as reference. So this is the case of call by reference. And we know in case of call by reference, the actual value of the variable also changes. So here in this question, we are passing the values as reference to this function named duplicate. Now inside this function, we can see that every variable, each of these 3 variables is getting multiplied by 2. So in case of call by value, there will be no change in the actual value. But here we are not passing the arguments as call by value, but we are passing it as call by reference. So the changes will be reflected in the actual value. So when 2 is multiplied by 2, it gives you 4. When 4 is multiplied by 2, it will give you 8. And when 5 multiplied by 2, it will give you 10. So its output would be 4, 8 and 10. Now let's move on to the next question. How to write a program to check if the number is palindrome or not. So palindrome is a number that remains the same when its digits are reversed. So here we have to write the program to check if the number is palindrome or not. So before moving forward, there are 2 things that you should keep in mind. That if a number is mod by 10, that is number mod 10, it will give the last digit of that particular number. For example, if there is a number 123, then 123 mod 10 will give you 3. And if we divide that number by 10, then that will remove the last digit. For example, 123 divided by 10 will give you 12 as an answer. So now let's have a look at this question. Inside the int main, there are variables like num, digit, reverse and n. And after that, there's a message saying enter a positive number. After that, we are taking the input num. And we are storing that num variable inside another variable, that is n. We'll talk about this later, why we are storing this to another variable n. Now there's the do block. Inside the do block, we can see digit equals num mod 10. Now to understand this, let us take an example as, let us suppose the number to be 123. Now num is that number and we know that 123 mod 10 equals to 3. That means the last digit of that number. So now digit is storing the last digit of that number. After that, we can see reverse equals to reverse into 10 plus digit. Now we know that reverse we have initialized as 0. So reverse equal to 0 plus 3. Now reverse now becomes equal to 3. After that, we can see in the next line num equals to num divided by 10. That means 123 divided by 10. And as we have already discussed, 123 divided by 10 will give you 12. Now this 12 will again go to num mod 10 and the value of digit now will become 2. Now this 2 will be added in the second line, as we can see, and reverse is 3 as we know. Now 3 into 10 becomes 30 plus digit, which is now 2, that becomes 32. And after that line, num equals to num divided by 10 will remove that 2 from the 12. So now the value of num is 1. Now again the num will go to num mod 10. 1 mod 10 gives you 1. So now the value of digit is 1. And in the next line, reverse value is now 32. So 32 into 10 becomes 320. After that, we will add the value of digit, that is equal to 1. So it will become 320 plus 1, that will give you 321. So after that, the condition of while loop terminates. And after that, we can see the reverse of the number is REV, reverse, because the result is stored at this variable. Now I'll tell you why we have stored num into the variable n, because we don't want to make changes with the num variable, that is the user input. And here we have used if condition, and inside the if condition all we have written is if the value that is entered by the user is equal to the reverse of that particular value, then that number is a palindrome, else the number is not a palindrome. Now coming to the next question, which of the following will give the size of object or type? So the right answer is the size of operator gives the size of object or type. Now let's move on to the next question. Which of the following is not a member of class? So the answer is among the following, friend function is not the member of a class. Now let's move on to the 31st question. That is, what is STL? STL stands for Standard Template Library. It is a library container that provides generic classes and functions. STL components are containers, algorithms, iterators, and function objects. So next question is, what is a friend function? A friend function can be defined as a function that can access private, public, and protected member of the class. The friend function is declared using the friend keyword. This function is declared inside the class. Now, next is, what is a copy constructor? A copy constructor is a member function that initializes an object using another object within the same class. The constructor is of two types, default copy constructor and user-defined copy constructor. Now let's move on to the next question. How does the strings are stored in the memory? Options are sequence, null, non-contiguous, contiguous. So the correct answer is the characters of strings are stored contiguously in the memory. Moving to the next question. What is inheritance? Inheritance is the mechanism in which we can create a new class, that is child class, from the existing class, that is parent class. This child class is also known as derived class, and the parent class is also called base class. And in the inheritance, child class inherits properties and behavior from its parent class. So our next question is, what is abstraction? Abstraction can be defined as a technique in which we only show the functionality to the user, that is the details that we want the user to see, and hiding the internal details or implementation details which is not necessary for a user to see. Now let's move on to our next question. What is the output of the below code? So here we can see they have used ternary operator in this question. So first of all, as we can see, there are three variables a, b and c, and 5 and 6 are the values of a and b that have been assigned to them. And at line 11 we can see a greater than b, question mark a colon b. So this is a ternary operator. Here a greater than b is the test expression. If this test expression is true, then the expression after the question mark, that is a, will be the answer, and if it is false, then the expression after colon, that is b, will be the answer. That means if a is greater than b, then a will be the answer, and if a is not greater than b, then b will be the answer. And as you can see, the value of A is 5 and the value of B is 6. So the test expression is false. So that means B will be the answer. So now the value of C is B, that is 6. So our correct answer is 6. Now let's move on to the next question. What among these is used to return the number of characters in the string? Option A is size, option B is length, C is both size and length, and option D is name. So the answer is both size and length will return the number of characters in the string. Now let's move to the 39th question. What is the output of the below code? As we can see in this code, the value of j is 10. Then the value of j is incremented. As you can see in the line 10, j++. So the value of j is incremented to 11. After that, j is added to 100. And at last, j is added to 999, which will give us the result as 1010. That is 1010. And this value is being assigned to I. So our answer is 1010. Now let's move to the next question, that is the last question. Pick the correct statement about string objects in C++. Option A is string objects must be terminated by a null character. Option B is string objects have a static size. Option C is string objects have a dynamic size. Option D is string objects use extra memory than required. So our correct answer is C. String objects have dynamic size. They are dynamic in nature, that is their size varies as their value changes. So they don't use any extra memory. So these were some important C++ interview questions.
Now with that, we have come to an end of day 3 of software development. I hope the session was informative and interesting. On the day 4 of software development, we will learn the dominant programming language, which is Java. If you have any queries related to any of the topics discussed in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all your queries. Until next time, thank you for watching, and don't forget to subscribe to stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.